Good morning. Welcome to the RISE discussions. This is the first in a series of small conferences taking place as part of the RISE project. A little bit more on that later. This is my colleague Roy. He's going to introduce our first speakers.
Hello, everybody. My name is Roy. I am from the Faculty of Engineering at Tel Aviv University, and I have the pleasure to invite Vika Kanar and Revital Nadiv, co-founders and entrepreneurs in the textile and fashion industry, and especially in the textile and fashion green industry, right? Where they co-founded Refresh Global, a new entrepreneurship in recycling and treating textile and fashion wastes, right? So Vika, please.
Good morning. Thank you very much for having me. It's a real pleasure to be here this morning, afternoon for others joining us from other places. I think that if we want to make a change, the name of this conference is called RISE. So we really are here about to rise, right, and to make a difference about a very big problem that most people are not yet aware of. So I really hope that this panel and whoever is joining us will understand the importance of why we're actually here today. But if you don't know yet why it's so important to speak about the textile waste problem, and maybe our presentation can help you with that. So like Rui introduced me and my team, and we are Refresh Global, and our idea is really to take textile waste and give it a new life at the end of the day. Let's see how we do that. I will share first a little video with you. Oh, the video cannot be played just yet, but hopefully then maybe we can go to YouTube. Yeah, maybe we should share it. So stop share. No. Okay.
The fashion industry produces 150 billion textile items a year. This is twice as much as what actually gets sold. Today, only 1% of discarded textile waste is recycled back into the textile industry. Over 85% of textile waste ends up in landfills or incineration. Even if we stop manufacturing today, existing textiles could last us for 50 years. 60% of all textiles are made from plastic materials. The fashion industry is considered to be the second most polluting after oil. Here is how we at Refresh Global solve this disastrous environmental problem. Our end-to-end solution is an urban microfactory where textile waste is collected, sorted, separated, and repurposed. This tech-integrated process allows us to rescue up to 98% of textile waste. Our repurposing process is divided into several commercial channels. Reuse, which applies to high-quality clothes that are identified through a mix of professional and automated sorting to be resold through a variety of retail channels. The rest undergoes an innovative recycling process and is turned into new fabrics, construction materials, or nanocellulose that can be applied back into the textile industry. Through our circular approach, we not only dramatically decrease the amount of textile waste, we also contribute to the local economy and help save costs of landfilling. We turn textile waste into industrial and consumer products that are locally manufactured and distributed. This is the true meaning of circular economy. Refresh Global, we work for a better today.
Okay, so let's go back to the presentation. And No, it's on Google Slide. Oh, I know one. Yeah, perfect. Okay. So let's talk about our vision. What you saw quick in the video is the vision of what we call the urban microfactory. I think that most of you, when you hear the word factory, you think of something which is oldish, old, those big machines. It's something that's dirty. It's something that you don't want to see in the city. But we think that innovation is all about actually taking industry, taking production, and putting it in the heart of our cities. We think that we need to be much closer to the process of the repurposing of raw material, which will connect us also much more to the idea of why there needs to be circular economy. So how do we do it? How does it look like in our vision? In our vision, first of all, we think that we need to collaborate with anybody and everybody that is involved in the entire process. Of course, the city itself, the city which is the biggest body responsible for waste, right? And it needs to, but also in the biggest need to find the solutions, because mostly the municipalities and local communities and even the local businesses, they don't have the means and the teams to come up with innovation. So this is why we need them to be with us at the table. And the next step would be everybody that is actually involved in the whole process of collecting waste and sorting it. I don't know what countries we're being joined by. I know my colleagues at the panel come from different countries, and I'm sure that you know that in your areas, it's mostly charities which do not have technology that can do that, the process. So this is why the third step really is the core innovation that we need to bring in, the entrepreneurship, the encouragement of bringing in new technology and helping promote that with all the stakeholders involved. How did we do it? I mean, this all sounds really nice as an idea, but our goal was to actually set out and test it ourselves. So we went to a city in Israel, and in the city of north of Tel Aviv called Kfar Saba, and we asked them to help us host our pilot, our proof of concept, where we collected in 10 tons of clothes in just about 2 weeks. And our goal was to increase as much as possible the number that we know today is globally being recycled, which is less than 15%. When you take every operations that are being undergo today, textile waste undergo today, and this is the number we got to. We really didn't think that we would get there, but this is what happened. How did we do it? As I said before, and this is something that we really, really believe needs to be the core of the circular operation. We got partners that came to us that are in one way or another part of the problem too, or part of the problem solving, like the university where we're here today, and then others like H&M or the big charities that really have to deal with those problems every day that they don't have yet a solution for. So what happened? We trained the people that are really in the heart of the operation, that oftentimes don't have the skills, and we trained them, and we saw that this really changed the whole situation on top of the technology, of course, too. So we have the human factor and we have the tech factor. What's the tech factor? The tech factor is a vision where the whole step, the whole process of textile recycling will need to be tech-based. It will start with the collection of textiles, which today, if you look around yourselves, if you think how it's being done normally today, is where you have to bring your stuff somewhere. If it's raining, if there's bad weather, then most likely whatever you have submitted will probably not survive, and so on and so on. So we really need innovation at the very first step of textile collection. And then, of course, the next step, the trained staff that I've just spoke about needs to be helped by some kind of technology which will help do the sorting, disassembling of the textiles which are being collected. And then the last step is, okay, what can be actually done with the whole waste that we have now sorted and that is now in a place that can be really repurposed? We know that traditionally cleaning materials and all kinds of products that have been created, which means extreme downgrading and downcycling of the fabric and of the material. So we said there must be another way. And the other way is actually, and we're so proud of it again because we're here today, is a collaboration that we have with the Tel Aviv University, with the Lab for Environmental Engineering, which has actually shown that cellulose, and when we say cellulose, we have to think, of course, almost about any kind of natural fiber. Interestingly enough, in warmer countries, we saw, especially with our research in Israel, almost 70% of textiles which are being discarded, but hence also bought and worn, are actually natural fibers, which means that these products like bioethanol and nanocellulose can be created out of them using a very interesting and innovative ozone technology, or the process of how this ozone technology can be used. The other option that we have come up with, or the patent option, is the creating of materials for different industries. What's the most interesting and new idea about this? The construction industry all over the world has been using textiles, I think, since ever. But what's interesting and what will be new about this is that normally they would have to ship them from somewhere else. These construction materials would have to be created from scratch, from zero, as we call it, from virgin materials. Our research and our development has shown that we can actually take those textiles that are shredded and have been discarded, and we can turn them into perfect, new, and very useful new construction materials. So we have really a huge opportunity here. Who are the people that are with us? Because of course it can be just me and my co-founder Revital, even though both of us come from the fashion industry, and we've seen factories, and we've seen the other side, the fashion weeks, and we've seen the industry, and we saw that we have to bring together a team of professionals that understand textile, that understand innovation, that understand engineering, and also understand the world out there and how to bring this together, because this is a very, very innovative field. And this is our winning team that has been able to do that. So I'm almost done actually, and I really just want to show you a few pictures of the impact. Putting together a POC during COVID is not the easiest task. And I'm so excited that we're not only able to do that, we'll also be able to bring together women. We took especially women at risk that have been hit very hard by COVID, whether they've been laid off or all kinds of other problems that we've been living with now for a year and a half already. And we gave them new opportunities, and we gave them a new purpose, and we got over 150 new ambassadors for circular economy. We went to labs. This is our research at Tel Aviv University showing what can be done with textile waste, which again has been such a big problem all over the world, still looking for those solutions. We've been able to create those new fabrics I've talked to you about that can be really applied now in many other industries. We have been able to bring together recycling factories which have never really dealt with textiles in that way, and we did something new with that. We've been able to create different types of pellets that now can be used as raw materials for new products, which is so exciting. And this is how we're doing this. We've been even been able to prove that at one point, further down the line, with our R&D, we'll be able to actually create maybe even consumer products out of it, and many other industries as well. The masks that also have been, of course, part of our lives for so long already. And I think all of us here, everybody that's joining, understands the problem of how polluting those masks have been. For us from day one, it was a very important task to actually provide an alternative and create something which is washable and durable, and is created of from recycled textiles. This is really our vision. So thank you so much for listening, for joining. We're very open for collaboration. We're very open to get together with other labs and other innovators, because we really, really believe that this change can only come if we all work together. So really open for business and looking forward to hearing from you. Sure. If we have another minute, Revital, would you like to present some of our product?
Well,
To show what we did already.
okay. So we gave the fabric that we succeed to do on the first run to a few designers, and this is something that Doron Ashkenazi, Israeli man designer, succeed to do. And he said that this fabric really feel like a real one, not like all the other recycled that we give. And also we succeed to print a digital print on it with no water at all. So also the print is very sustainable, very green too. And another Israeli designer, which is well known in shoes, succeed to make from this shoes. So this fabric is not only for the construction, we can make his value even better and make a lot of different other products with it. And as we can see here, we can even thread fabric that until now was very hard to do, like lycra, and start doing what we can do from is start testing what we can do, what kind of products we can make out of it too, instead of dumping to landfill.
And we're more products in the pipeline. So contact us if you want to know more.
Thank you very much. Thank you very much. I'd now like to introduce Dr. Gloria Yao from the Hong Kong Research Institute for Textiles and Apparel. Gloria, would you?
Thank you. Thank you very much. Very happy to meet all of you here. I'm from Hong Kong, so good morning. Here is the afternoon. Okay, today I will share what we have done on the textile recycle and introduce our organization, HKRITA. Sorry, I will need a slide show. Yes. Okay, so I will share or in the textile recycle and how HKRITA works on technology development, partnership with industry brands to recycle municipal textile waste. Sorry, too fast. So you can see this actually is cut from our web page. So in the web page, we state that we provide a one-stop service for applied research, technology transfer, and the commercialization to benefit the textile and the fashion industry and the society. So the background of HKRITA, actually it was set up in 2006. The background is the Hong Kong government adopted innovation and the technology as the key strategy to promote the economic development. So set up the innovation and the technology fund to support the applied research. So our operation and the research project are fully supported by Hong Kong government public funding. We conduct applied research, supported the textile and apparel industry to increase the added value, productivity, and the competitiveness of Hong Kong company by upgrading their technology level and introduce innovative ideas. So textile and apparel selected as the focus area. It is because Hong Kong is an international fashion hub and clothing global sourcing center. So that's the background. Our organization actually is a triangle. The background is government provide the policy and the funding support. Industry brands feed us their demands, allow us understanding their pain points. And we also partnership with university and the research institute for technology development. With this organization triangle, this structure as a platform, we can access R&D talent, industry, research funding through HKRITA. So here I listed our key research themes. First of all, we focus on sustainability and also take care of the industry advantage and the social benefit. So HKRITA has devoted considerable time and resources in this research themes. Hong Kong, with around 7.6 million population, every year there are over 125,000 tons of textile waste was produced, and only 4% was recycled. As Refresh reported, that probably European is over 15% textile waste was recycled, but in Hong Kong, the data is really low, only 4%. So that is a really big challenge to us. So address the biggest challenge of textile waste, the 1,000 tons of garment waste. We developed the so-called smart sorting technology for reuse, resell, and recycle. So that will help us to achieve a circularity. The most efficient way we would like to keep the most value of the textile waste, make it effectively for reuse and resale instead of recovered fiber. But in the end, certain amount we have to handle as a recover as the fiber. So this is a diagram what we conducted the research in this project. We are developing an AI-based garment type sorting. So we sorting different type of garment, jeans, coat, suit, pants, vest, coat. So that's the big piece, always the high costs and the high value. So high possibility for resale and reuse. So first of all, we do the type sorting. So can classify it into different groups, and the charity or the second-hand store can resell and reuse them. And also for that piece cannot for resale and reuse, then we will process the fiber recover. So we identify the material, the fabric construction, color, and then do the sorting. To apply the appropriate mechanical recycle process, we can recover most of the fiber and keep them at the ideal quality, can for the yarn spinning or for garment making. So textile also consume a vast quantity of natural materials like water, oil, and the land, and also involve a lot of toxic chemicals and generate a huge amount of carbon emissions. So how we convert such kind of waste to new resource of textile material, that is a big topic. So this photo shows we develop a chemical process. We targeted the most challenging part, the blended fabric, the cotton and the PET blended, which occupy a big proportion of textile material. So use the hydrothermal process, use a certain heat and the green chemical, and half to 2 hours process can very effectively separate over almost 99% of cotton PET blended. And the polyester keep almost its original property, molecular weight, no significant reduction, and the cotton becomes cellular powder. So we can use that cellular powder for repurpose, I will introduce later. And this system has been actually is in the November last year, brand Monkey, H&M sub-brand announced will created the brand first collection use the green machine, the hydrothermal system. They aim to rolling up the process on a larger scale by later of this year. So this system has been scaled up in the industry and will have the collection on the market later of this year. Yeah, this they announced in the November last year and will launch later of this year. And as I mentioned, the cellular particle from the hydrothermal process, we develop a super absorbency polymer. So this super absorbency polymer is from cellular particle. Normally, the super absorbency polymer in our diaper or healthcare products is the petroleum based, alcohol based. So that part is now have the challenge on the biodegradability and the environmental friendly. And this cellular-based SAP actually is biodegradable. It can absorb more than 30 times of itself body weight. And now we are scaling up the application of this SAP in real agriculture application. We partnership with an industry partner to evaluate its performance in real cotton plantation in a real farmer scale, talking about 20 acres. So hopefully I can report to you the updated data in the end of this year or beginning of next year. So this is a garment to garment, a mini meals in retail space. So this is so-called is the first one-stop closed loop garment to garment recycle in a system. It is in a transparent double layer glass box. It is set up in Hong Kong. Once older you want the garment to get into and slow sensitization, fiber opening, spinning, and the garment making process to make it as a new garment again. So it is we take this as an educational tools, allow people experience how unwanted garment through the G2G system become a new piece of garment. And this system also can be demonstrated for recycling products and the marketing. And the whole process is without water and the chemicals. So it is a dry process, all the garment in and come out as a hydrogen and clean and a new piece of garment. So and this system has been duplicated in Stockholm, an H&M retailer store named Loop. It was set up at the later of October last year, and now through the almost 1 year's process, it's quite a smoothly operation. And for the previously two cases, we partnership with the overseas brands and overseas manufacturer, and the G2G actually is located in Hong Kong, a retailer space. And here I will introduce industry scale we call the upcycling textile recycle system. We partnership a Hong Kong local industry partner called Novotex. From 2017, we developed this upcycling system. And it also is a dry process without chemical. And all the garment in and certain quality fiber was recovered from the process I will introduce later. And it was set up in Hong Kong typo industry estate. So that's the interesting part is Hong Kong textile industry have offshoots 30, 40 years ago. It is the first mills come back to Hong Kong after so long time. The system, the old piece garment, slow the ozone sensitization, material preparation, color sorting, smarter sorting system, and the fiber process system to recover the fiber. And the fiber quality is good enough for yarn spinning and the garment making. So that is a real industry mills set up in Hong Kong. You know, Hong Kong, the land cost is and the labor cost is so expensive. So that is the cases. We work with the brands, industry, and or by ourselves set up a pop-up store, the G2G, for directly communicate with our consumer. And our law as a research institute, as a platform, and with the support by the government and industry support and research institute, university support. So we have the capability and we have the in-house team to do the research and build up the technology and the transfer to the industry to benefit the industry and the society. So welcome, join with us. So we're also looking forward to partnership. All of you build the useful technology can benefit all of us. And thank you.
Thank you very much, Gloria. Thank you for sharing your screen. I'd like to introduce next Wolfgang Ipsmillier. Wolfgang is an academic from the Technical University of Vienna, where he is an expert in textiles recycling for a variety of different technologies. Wolfgang, please feel free to begin.
Thank you very much for the kind introduction. After these very interesting topics that we've already heard, going directly into business models and into adopting these technologies on an industrial scale, I would like to give you some overview and some background on what things are important when we're talking about textile recycling and textile collection. Okay, first I will try to share my presentation. Okay, I hope you can see the presentation now. I think that's the case. Okay, so when we're talking about textiles, I think the first thing that we need to think about is the amount annually produced. So we've heard already that we have a huge number of textiles produced annually, discarded annually, and if you have a look at these graphs, I think we can quite clearly see that this is mostly due to cotton and polyester production. And if you compare this to other commodities like crude steel or aluminum, then we see we're, well, not quite at the stage of crude steel, but still exceeding aluminum. When we look at the shares, I think we are fair to say that 80% of all the textile material produced is PET. However, as we've heard already, we find a huge amount also of cotton in these textiles. So we will have to consider this too. When we're talking about textile recycling and the sorting and the management of textiles, there is several implications to that. So the first thing is thinking about, okay, why is thermal recovery maybe not such a good idea? I've put together some figures to that. So if you have a look on the right-hand graph, you can see that the reclaimable energy, and this is just to give you a rough overview, when recycling fibers, or sorry, when thermally using these fibers or garments is fairly low. So this is also why EU, and I've explicitly taken this out, amended the Waste Framework Directive that it's set up, and textiles are now explicitly also part of municipal textile waste, and all the criteria that apply need to apply to that too. Of course, the first purpose would be reuse, and recycling is the second option, or even the third option, if you consider feedstock recycling. But however, as we have seen, not all the textiles will be feasible for reuse, and you have to deal with the ones that you cannot reuse in a recycling approach that's sustainable and also economically feasible. When we're thinking about these steps to recycle, then we first, well, it's quite obvious, need to collect these items. I mean, there are collection systems set up already in Europe and across the world, and I'm sure also in Israel, where you collect PET bottles and we collect paper, and where there are approaches to remanufacture that into products. This is less so for textiles for the moment, and well, one apparent problem is that textiles are in many cases blends of different materials. So there is different approaches on collecting these textiles in similar ways, such as containers or bring back systems. However, there is a sort of, despite the technologies we have, of course, but there is a sort of a gap or a lack of understanding what you can do with these collected items. Okay, so this is not for you to study in detail. Also, I'm afraid it's in German, so I apologize for that. But it should just give you an overview that sorting means that you have quite a lot of different primary sources where you can get them. So the left boxes basically say that the consumer brings back that there is a separate collection from the consumer, and on the right hand side you see that there is also a post-consumer or pre-consumer industrial waste, well, in future there will be a need for automated sorting in that. So we've heard interesting approaches with AI detection. The technologies that are used at the moment and that are tested on quite large scale is NIR detection. However, this needs to be extended in the future. What you can get back then is, if you see the lower line of this graph, well, secondhand clothes that you still can export to countries where they're needed, that you can reuse in your own business system. There is another option that has been the option of choice for a long time, is that you shred these textiles and get back hydrophilic materials out of that. But of course, this is not the only part that you will get. So you need to deal with the others too. And after detachment of things like zippers or eyelets, you will get a textile material pool for potential recycling. So, and what I wanted to show you with that is only that you need to think about which streams would you commingle, which streams do you need to deal differently with. So, as our colleague already mentioned in the first presentation, there is mostly private collectors, and this is just to give you an example how it's done in Vienna. There's charitable organizations that collect these textiles, and of course then later on sell a huge part of it to to countries abroad, and a small portion, or a fair portion, is used as cleaning and wiping racks, and well, the other part is not so known how to deal with at the moment. So this is a possible thing for recycling in the future. If you consider the changes in legal developments, then of course you also will see that in the future this problem will increase. So you will have more or a higher share that is due for recycling in the future. There is also a consideration in Vienna at the moment, and I'm sure quite spread across Europe and to Israel, that you should also set up a municipal collection system. So this is at the moment tested in Vienna. Well, and the outcome should be, is it same quality? What can we separate? Is it possible to separate reusable textiles from slightly damaged or contaminated textiles? And that's something that for sure for a textile system, recycling system, a circular economy approach needs to be thought about. Well, how this looks like is basically, we've seen the sorting. I mean, this sorting is more manual as the automated sorting that we saw before. Basic idea is just that you think about which material streams will you get, which materials which are commingled in these textiles. So basically, what is being done is there are sorting campaigns that are used to identify material complexity and the content and shares of different fiber materials. And there is also recently one sorting campaign that was carried out at TU Vienna, and we found out that, well, from 70 or even more theoretically discernible fractions, there is a practical importance for roughly 40 if you consider recycling in the future. So which depends on content of cellulose, share content of PET and other synthetics. This is just to give you also an overview, and it's not judging anybody, but basically it with different sorting campaigns and different studies carried out that showed that for Germany there is a possibility for or that's already carried out for separate collection by around 3/4, whereas, for example, countries like Sweden, the US, or fairly to say also Austria is quite not so highly advanced in that. So it's still split to private campaigns and to these bring-in systems. And well, the amount of recycled textiles that you can see on the right-hand side is still quite fairly low, but we will increase that in the future. I'm quite sure with a lot of these technologies that we have already seen and that will emerge. When talking about sorting, the apparent technology at the moment is NIR separation. So I've just put on this slide some of the projects that were carried out. So there is a huge project that was carried out in Sweden. It's still an appliance that is still in operation. There was also a project in Germany, smaller one, and there is a industrial sorting plant in Belgium where they try to discern these different fractions, quite as such as the ones that I showed you, the kind of the 40 fractions that we can get, and even more depending on the use, on the purpose. So you can be quite flexible in that. Still, at the moment, there is a question of accuracy of the detection. So this is something that there is a need for development in this part. So there is a research that was carried out that set up recognition classes, and depending on the material content and how many materials were contained, they set up this detection for cotton or PET. So to see what the accuracy is. There is also smaller research projects, for instance, like the research project in Finland, where they try to, and this is quite interesting, try to construct small semiconductor sensors that would give you the opportunity to directly, at a sorting facility, to directly detect, okay, what materials do I need to expect in these textiles? So even if you don't set up a huge NIR automated sorting system, this could be quite coming quite handy for manual sorting strategies that will still have a place in the future. After we have thought about now sorting these textiles, the question will be, okay, which options do we have for textile recycling? Can we see textiles as commodities such as paper or PET bottles? And yeah, well, the answer is I think we cannot see it this way, because as you see on the right-hand side, there is a quite elaborate production chain for textiles where you have different primary processes that are carried out depending on if you have natural fibers or man-made fibers. And then there is yarn production. You produce the fabric and you have wet processing and tailoring. So the basic saying about that is that you will get fiber blends, that you have to deal with fiber blends, also fabric multi-layers, and that you have additional substances that you need to think about. For example, for every recycling process, a content of heavy metals, if you want to reuse it on your skin, may be a problem. So this is something where we have to put our efforts into and develop recycling technologies that will guarantee for contaminant-free material streams. You have seen the graph on the right-hand side, and I just added to that a part on the left side. So let me just explain this to you a little bit. So basically, what's going into the textile processing chain is fibers, is additional materials. So what you basically would like to, if you cannot reuse the original garment for its intended purpose, is that you will feed back fibers to generate new fabrics. If you cannot do that, you would like to feed into the system back polymers, where you can make out of that new fibers and new textiles. So basically, this is done with monomaterials at the moment, where you have mechanical recycling lines, or where you have where you get back individual fibers. And the other option is a physical, so-called recycling approach, where you would have recondensation, and this is mainly used for PET, and technology is quite emerged already. So this is possible. Problem with that always is that if you commingle these material streams with too many contaminants, or with other fiber materials that are in there, then there will be, to some extent, a problem in recycling. So for instance, you can imagine with recycling lines, you would have a filter clogging, or with mechanical recycling and tearing lines. If the fabric is still too dense, then you would generate fibers of very short length that you would not be able to reuse. There is also, because it was already mentioned before by our colleagues, there is also, of course, always an option for a reuse as cleaning and wiping rags for short fibers and so on, but also, and this can vary in a large range from very low class to very high class, as we've seen already in the first presentation, quite high class nonwovens or textiles that are made out of material mixes. So that's still an option, and if it gives you the desired quality, well, then that's a good thing to go for. So just to give you a short overview of how this would look like, with the mechanical processing, so the fiber recovery, you basically have a tearing line with drums with needles and pins. Well, it's quite elaborate, but the principle is quite easy, where you would feed your coarsely shredded material, and after opening in these drums, in these machines, and you can have several units, then you would get back fiber material that would be feasible for respinning. I took this from the company La Roche in France, which is, to my knowledge, the largest company that is doing these kind of machinery. So that's always a good option if other fiber materials do not pose a problem, or if you have single materials. For instance, if you have pure cotton, then of course this is an interesting way to go. The other option that I showed you basically is the physical core processes, where you have melting and also in this case recondensation. This is for PET quite often a prerequisite so to get high class material out of it again. And quite interestingly, I found this plant in South America, where they're using a regranulator, where they are processing fiber waste to regranulate that can be used later on for respinning. As I said, always a problem. It's not the same as if you took materials from plastic bottles, because you have different densities, you have a commingling with other materials, and the hygroscopicity is a problem. But there are technologies emerging, and so this is already feasible. So if you would like to go for a material that is high in content of PET, or almost pure content of PET, or other meltable synthetic materials, then this is a very interesting way to go. And also, I want to once more have you to keep in mind that you should go for the lowest cost option if it's feasible. So that basically means you always would like to not go too deep into the production chain, to go back too deep into the production chain, because of course this is more costly. Now I've talked about mixed textiles. So basically, and I've highlighted this by this green box around the two main options that I showed you for now for direct fiber recycling, for melting and for recovery of individual fibers. There is always this problem of multi-material textiles, and in the over the past few decades, and especially past 10 years, there have been research activity towards biochemical or chemical or feedstock recycling options. So the basic idea behind that, and this can generate more value even, is that if you have mixed textiles, you want to take out one component to generate components that you could use as a feedstock or use as a feed material, so to speak, in these classical physical or mechanical recycling processes. So this would give you the option to recycle fabrics that were not feasible for recycling in the first place before that methods emerged. As I've said already, and I've depicted it a little differently on the right-hand side, is that you always have to think about how much cost effectiveness and resource efficiency it gives you when you go back in the production chain. So as you see, if you go back to the polymer, of course, the energy, and this would directly relate to greenhouse gas emissions, that you can take out of that is lowest. However, if you, as I said, combine it with other processes, then it may be quite beneficial, because it would facilitate recycling these textiles that you could not recycle beforehand. And well, of course, processes that are used for these chemical approaches are any kind of depolymerization processes. So I put it as lytic processes with acids, bases, and combinations thereof. And what you would get back is monomers or oligomers. However, sometimes, or in many cases, so to speak, the quality of these materials that you can back will only facilitate using these materials as if you break it down as fuels for other applications. Well, this is not the path that we should aim to. So we should think about generating high quality products out of that. And that means you need to have selectivity on your processes. And selectivity also led to the invention of the enzymatic recycling processes. And that's the reason I put this as a separate part of this presentation, because it would facilitate the degradation or the depolymerization in a highly selective manner, so that you can generate out of that monomers that you can generate. For instance, from cotton, you can get back glucose or other sugars, and these can be fermented into ethanol, or you can use them as a high quality source with a low impurity level for the production of fine chemicals. So basically, there is a lot of research carried out on this feedstock recycling methods and methods that would facilitate the recycling of multi-material textiles. One of that, and I just took out some because there is a huge bunch of research carried out on that, but there are different approaches. And one interesting one was catalyzed alkaline PET hydrolysis to obtain cellulose fabric and PET monomers. Another one would be acidic disintegration, where you can recover cellulose powder. As we've heard in the presentation before, there are also very interesting approaches using hydrothermal methods to do so. And as I've said, selective sequential depolymerization with the use of enzymes is quite feasible for cotton. So if you have a high share of PET, for example, so polyesters, and you want to degrade the cotton, you can use enzymatic processes. This is, however, not so far developed for degrading polyesters and other materials at the moment, but there is a lot of research going on there too. So I'm happy to share later on if you are interested in that. In terms of projects that are carried out on recycling and the textile management, there is basically, well, there is a lot of research going on. There is few industrial scale processes. There are a lot of these processes emerging. I just took out two that I found quite interesting. So the first one is using cotton waste to produce lyocell fibers. So basically, lyocell is a cellulose fiber that you can get out of, normally you would use wood and you would use chemical pulps, and then you would get these fibers. And the company Lansing kind of made it possible to use other sources. So they're developing these technologies at the moment. Another one is also dealing with cellulose waste is Renewable from Sweden, where they are trying to make pulps out of that. Of course, this is not the full list of processes. As we've heard, there is a lot of research going on, and there are very interesting projects and industrial pilot scale operations, as from our two colleagues before. What I would highlight in that is that we should not focus on only one possible option. I think it's the bunch of many options that we need to always find the best solution for a certain input material. if we've generated input materials and we know the contents, this is also something that can lead to quite high-class products that we can get out of that. Another consortium that was conducted in Austria was the Text to Mud project, for example, where there was a different approach. So there was the approach, as I mentioned, to depolymerize cotton, get a glucose solution, and to recover the polyester. And this polyester was used for respinning into new fibers, and they were partially used in new textiles. As far as business models or design for recycling are concerned, there are also projects going on that deal with the logistics behind all of that. So you cannot just talk about the recycling. It's also about how do you make sure, or is it possible that you don't need to recognize in sometimes quite complicated manners which materials are commingled. So is there a possibility to implement this information in the first place? And there is one interesting project carried out, or that was carried out in Germany, for example. I'm sure there are lots of others where they concerned intelligent labeling. So when you closely cooperate with the designers and think of how could you implement the textile with information about the content, and they were doing it in this approach, and also combined it with eco balancing models to have an overview over this whole chain that is concerned with that. Finally, just to sum this up a little and to give you an overview also on how this could look like for a material stream like a multi-material textile. I took a case study that we carried out at TU Vienna for personal protective equipment. So what you need to know is that personal protective equipment in a lot of cases, or in many cases, most cases, consists of various materials. And in this case, it was a fabric, or were fabrics from model substances at first. After that, we took post-industrial waste and real work uniforms, so to speak, where you have a flame retardant pigment in cellulose fibers and where you have synthetic fibers. In this case, was aramide. So the idea was, well, okay, using this enzymatic hydrolysis approach, and degrade in this case, the viscose fiber, so cellulose fiber, get back the pigments and get back the synthetic fibers. And quite as I said, with mechanical recycling, quite straightforward, use this for producing new fibers and eventually new garments out of that. So our idea was to make a showcase for that. Basically, I don't want to go into too much detail in that. I will be happy to discuss this with you. We had lab approaches first, and then after that, what we did is using our technical facilities and implement a quite simple approach in a reaction vessel where we put this material, and you can see here at first this is the model fabric, the upper middle picture, and the lower picture was post-industrial waste. So this is trimmings from t-shirt production. And basically what we did is immerse it in a enzyme solution. Of course, there is potential for optimization because in this case we used quite a high content of these enzymes. So there is also a need to consider not losing this operating resource, but we have options like membrane technology for that. And after treatment, what we got out is basically what I said. We got out a pigment that we obtained, and we got out the fabric. Okay, and after shredding, opening, and tearing, we got back reclaimed fibers, and these fibers were used in regenerating kind of the original fabric. So we did this together with a company that I mentioned on the last slide. Why am I showing you this? The reason I'm showing you this case study is that I think this will be possible for quite a lot of textiles. So there is quite a lot of research carried out, and there may be also other approaches like thermal disintegration of the cellulose. So maybe there is also a possibility in taking out crystalline cellulose or other powders and so on. So there's a lot of options, but the basic idea is that you combine all these technologies, and in this combination that you would get most benefit out of that. So just to sum up, in short, we can fairly say there is a need in dealing with these waste streams because of the sheer amount of textiles and fibers produced annually. What I also can say from my experience is that we need separate collection systems, and these separate collection systems should also not just collect all the textiles in one container if you have container collection, but we should give the consumers the option to decide for themselves which textiles are in mint condition and which are contaminated. And this is something that we try to carry out in Vienna at the moment. I encourage also others to do so. Yeah, what I put here is forerunners and latecomers. This is not to pinpoint anybody there to say that this is bad or good. The only thing that I'm saying is that there is still a lot of potential, and that there is potential on quite low level of effort that you need to introduce for the first options. Then, of course, what we need to consider is in the future, by changed legal developments, will there be more textiles that will have the need to be recycled? Will we still have the amount of half of the collected is sold as secondhand? So this is something that we need to keep in mind when you think about the annually collected amount of textiles. And of course, finally, recycling will be necessary in the future. There is a lot of different technologies. We should use all of that. I'm quite encouraging everybody to have their say on that. And what I think is that new technologies and combinations will surely fill the gap in the future. And it is quite a huge opportunity that we have to make this system more circular. Okay, so that's was it from my side. And in the end of our discussions, I will be happy to discuss with you all the implications.
Thank you very much. That's very good. Brilliant. There's 3 excellent presentations, all touching on themes of circular economy, processes for sorting and separation, and a variety of recycling processes. We have 45 minutes now for a discussion between our presenters, and we have a series of questions from the audience both here and on Zoom. I'm going to ask some questions to the individual presenters, and then I believe you presenters almost certainly have questions for each other. I think it would be very valuable to see that discussion. So firstly, for Refresh Global, what are the barriers to implementing this technology more broadly?
Okay, so the barriers, something that I've been actually thinking about a lot also during Wolfgang's presentation. It's very interesting that all the 3 presentations that we gave, where you could clearly see that we're all standing in a different, we're coming from a different perspective, right? We are more of a startup, HKRITA being an institute funded by the government, which means there's been already a conscious decision by the government, of course, also originating from the fact that Hong Kong has a tradition of textile production, as we've heard. So that was, I guess, a very natural need and understanding that there needs to be also funding to see how the fashions problem can be solved. And then I feel Wolfgang is really kind of connecting a bit of everything, because some of the things we saw were also on the startup level. Well, there's been some practical experimentation at the university, but of course a lot of research and a lot of kind of deep diving into the whole the spectrum of the solutions that can be. So to respond to your question, I think that I mean, for me, what's most interesting is to understand, okay, how can we all get together? Because I feel that that's what we must do, because the gap between the research and even the solutions that are out there right now, and not only the scalability, but the possibility to integrate it into the industry is still very big. So I feel that we really must find a way to join forces, and we need all the stakeholders that, whoever remembers our presentation, that we mentioned that we must have all the stakeholders involved and interact in order to make this happen.
Great, thank you very much. And you've mentioned that all three presenters in this particular discussion are coming from different perspectives, but what shift in perspective do policymakers, legislators, bureaucrats, people who work for the government, what shift in perspective do policymakers need to make in order to bring this kind of technology into its fullest realization?
Right. So it's actually funny. I was thinking that Wolfgang would mention it. He did mention it towards the end. Actually, the EU is coming out with a regulation that already has come out with a regulation which will come in force in 2025, which will oblige all manufacturers and importers of textiles to collect the textile waste separately, which means practically that there will be, as we know in Europe, and maybe other places, not yet so much in Israel, sadly, that there are bins for almost every kind of different type of waste. And so now what will happen starting 2025, there will be also separate bins for textiles, which of course also means that the textile waste will increase dramatically, or the separated single textile waste will increase dramatically, and there will be the bigger need for solutions. So coming back to the question, this is a a first very important step to really make a difference that the EU has taken about. We know that the EU has put the goal to reach circular economy very high, and it's also dripping down to textiles. I think also that most governments, or too many governments, that we saw also in the gap that Wolfgang showed, the 70% in Germany and the 15% in the US, the gaps are still very huge. Even in the EU itself, the gap is between, again, countries like Germany, which I saw numbers of even 75% of collection and that being installed, and up to 5% in other EU countries, which means hardly any textiles are being collected, and definitely not in a regulated or in a ordered way. So that means that government, unfortunately, there's no other way but coming out with regulation, but also on the other hand, coming out with incentives. If most fashion and textile producers today, they have no incentive of coming up with a system for the take back and for the dead stock collection, then of course there won't be much of a solution, and there won't be much of a progress in coming up with those solutions and implementing them.
So there are lots of options for policies of way governments can improve the circular economy.
They must, I would even say they must, because again, otherwise there won't be real change.
Lastly, and I'm sure we'll have more questions from the audience, but lastly, does the sort of technology that Refresh Global is working with, would this benefit from a centralized approach to other economies of scale, or would it work better as a decentralized place, lots of different units all over the city?
Right. So I think first of all, what's important to understand is that we have, of course, even though we're not an academic institution, we have people on our team that come from the academia, And that was also driving for us, for us to research and understand, okay, where we should focus our work on. And it might seem that we're a bit spread, but that's also another reason. And as we just said, because this whole ecosystem is just so early yet, you know, we really, I mean, even after the amazing and all the impressive solutions we just heard about of the research, ultimately, if we go out right now in the industry, there's really almost nothing happening, right? Except for, you know, I'm not talking about the progress that has been made, let's say, with PET, with the recycled polyester, but if we're talking about blended, if we're talking about where the industry stands, we're still, it's just hardly anything is really still happening, definitely on a scalable basis. So that means that for us, we said, okay, we can't just focus on something very narrow. We really have to look at this microfactory approach, which will bring together all the stakeholders, everybody that is on the one hand the problem owner and on the other hand the problem solver, to work together to come up with better solutions. So yes, we think that it needs to be decentralized also because we want to adapt it to the local situation in places where collection is already working much better in terms of the collection amounts. We might not have to come up with, you know, and train the people to set up a whole collection system. We can go into what's already happening, into the infrastructures and say, okay, now let's add technology, right? That was, if you remember, I was speaking about, and again, we saw it also in Wolfgang's presentation, the charities like Red Cross and Humana and so on, which are the leading ones in Europe, they all do an amazing job. They have already a system in place. They have, you know, they run their charities all over, and they assume that they have some kind of a supply chain, which is probably also not bad either. But yet they lack technology, they lack the training for the staff. So we need to be not only decentralized, we also need to adapt it to the local situation, which really think, in our view, is the concept which will make the whole difference.
Great, thank you very much. Wonderful. Gloria, we have a series of questions for you. Wonderful. Your presentation was a fantastic overview of some HKRITA's work, not just research, but some of the pilot projects and a lot of the insight as well. You mentioned briefly an artificial intelligence method, an AI method for the sorting of clothes. Can you elaborate on this, please?
Okay, so that project, actually we targeted the massive textile waste. Actually now the sorting for the recycle and the reuse, that stage mainly rely on manually sorting. So sorting the garment tab, the cleaners, and the how fine the garment it is. It's now is manually. I visited one recycle site, and actually that labor intensity is very high for that part. So that's bring me the idea, say that how about we develop an AI technology to identify the garment tab automatically. So currently our project is ongoing. So we utilize the image process, identify the key feature of the garment as a fingerprint feature. So combined to help us identify it as a jacket or a coat or a t-shirt or a shirt. So that is our approach.
Okay, and this includes sensing technologies, obviously cameras, but there was some mention earlier of some other spectroscopic technologies.
Yeah, we also integrate with the spectrum technology as well. Yeah, and we also applied as a part of the spectrum technology, and the visual measure is the visual technology and then integrate with AI. Yes.
Understood. Okay. Now the garment-to-garment plants. There's one in Stockholm, as I remember correctly.
Yes.
An extremely exciting idea. You bring some clothes and you get some more clothes at the end of it. Are there plans for expansion?
Yes, actually we have a long waiting list from different brands and industry partners. They would like to have this system. And due to the COVID-19, the traveling and the engineering setup, that's the slow or schedule. So, but yes, the one exactly the duplicate one in Stockholm is ongoing, is already operated, and the one is in Hong Kong, and I foresee we'll have more system in Asia, European, or USA. Yeah.
Understood. And could you specifically elaborate on the business model of these garment-to-garment
Yeah, that is, yeah, actually that is an interesting part. We take that as a pop-up store. So we run the business, the consumer can send us a wanted garment, old pieces, or some lovely story is a couple, and send us 2 garments for each of them, and then make 2 new, combine them, the material, as a generate a new garment for them. So that's a very funny story. And they send it to us. And for our research project, we take that as a researcher cases. So from now, till now, we already accumulate over 500 cases. So that is a database for help us identify what's the engineering setting, the material combination, spinning technology to make the older garment can be the best performance for as a new garment. Actually, that's the background of the technology under developing. And meanwhile, this site also is an educational tools. So many people, university students, and researchers, companies, brands visited there to inspire their business model, how to make the garment really close the loop. So that's why HM, the store name loops. Okay, so, and also could be the marketing tools to demonstrate the different type of recycled products. So that is the business model at this moment. But I think after it transferred to different brands, they definitely can input their own features to customize for their purpose.
Okay. Thank you very much. I have a question from the audience. There was also a mention in your presentation of a polymeric material, a super absorbent polymer. There was a 30 times hygroscopic, if I remember correctly.
Yes, right.
Was this developed within a laboratory at HKRITA, or is this part of a partnership with another organization?
It's from our lab. Our own lab, our own research team developed this. Yeah.
Okay. Wow. And can you elaborate slightly on this, or is this?
Yes, the raw material is from the cellulose particle recycled from the hydrothermal system. That's we break down the cellulose to separate the cotton and the cotton from the PET blended. And so the cellulose particle, we use the close linker to make it super absorbency. So it is biodegradable because it's cellulose based, so it is biodegradable. So currently we use it as additive in the soil for the cotton plantation. And yeah, we have data support that it can save water irrigation.
Okay, I understand. That's fantastic. Thank you very much. I've got a couple questions for Wolfgang here. Wolfgang, thank you very much for your presentation. It was an excellent overview of a large number of recycling technologies. The obvious question is, in this large overview of different recycling processes, to what extent do they overlap with recycling processes for other waste streams?
Yeah, thank you for that question. That's something that's really important to discuss, I think. Well, I mean, obviously in plastics recycling, if you consider PET bottles, then these technologies, so the classical technology for recycling PET is melt extrusion. And these melt extrusion processes would extend also, of course, to fibers and fabrics. Also, there is some kind of competitiveness, or some competition going on between between PET bottle production and fiber production, because there is already a lack of PET for bottle production, because fiber industry, or vice versa, needs this raw materials. So there is certainly a connection in this purpose. What I mention is that, of course, fibers are somewhat more difficult to recycle. So these machinery that you can use for these melt extrusion processes needs to be adapted to some extent, needs a more elaborate recondensation step, so to retain the polymeric structure. But nonetheless, I think this is the clearest this is the clearest overlap. If you go into other waste streams, for example, then you have you can consider that in automobiles you have also a huge amount of textiles. There is recycling technologies that are slightly different. So basically automobile recycling is done differently than with textile recycling. So there you have an overlap in that you have textiles in cars and that you have textiles, but there is no common recycling approach to that. Well, so that's something that you could also consider. However, in automobiles, the quality and the material used would normally not be feasible for reproducing textile garments out of it. That's more. There may be a larger connection or a better connection to non-wovens production, which is, by the way, underrated, of course, because I think if you do this properly, as we have had an excellent, and I think it was non-wovens, we have had an excellent example in the first presentation, then there is still something that you can do. And this is also the approach that I'm basically proclaiming, that you don't have a single reuse, but you try to build these cascades. And then, of course, you need to think about how to connect material streams that are not hitherto connected. Well, with other technologies, I mean, as there is so many different materials, but as we've seen, most of them are cellulosic or polyesters. There are polyamides, there are polyolefins, but this is not so much for textile garments, for apparel, but it's more for carpet production, for example, in the US. So this could be a material stream that is also treatable or possible to being dealt with in plastic recycling approaches. So basic connection. I would say the first thing that comes to my mind is the plastic recycling approaches. The other ones, are not so closely linked, I would say, for now. But there is an option that we could link that. I mean. What also comes to my mind is that if you, for instance, if you have materials that have various layers, have various components in them, then of course you connect the textiles or the textile treatment closely to mechanical sorting, closely to mechanical separation techniques. That's something that could be very give you synergistic effects.
Great, understand. I think one of the most radical technology sets that you discussed was selective depolymerization.
Yeah.
This refers back not just to the polymer recycling you're discussing with textiles, but also the overlap that has with polymer recycling more broadly. Can you let us know any exciting new developments within selective depolymerization?
Well, as I've said, we've already also done two projects to that, but there is fair to say a lot of research going on. I think it really picked up speed in the last 10 years or so. There is, for instance, research going on in Sweden. This stems from the background of paper industry. There is also, by the way, I forgot to mention that there is also a huge connection to circular bioeconomy. If we think about the reuse or the use of the depolymerization products in biorefinery. I mean, this is something that can also give you a synergistic effects. But as for the question, there is, for instance, interesting research going on, and this is also, I don't just want to mention Austria, but I just know this institute. This is University of Life Science that carry out projects in decomposition or depolymerization of wool, depolymerization of PET. And there are other institutes that are dealing with that. So I think despite cellulose depolymerization, where the process is already quite, the TRL, the readiness level is quite high already. I think this is on the step of being introduced into industrial processes. So besides that, there is mainly research in depolymerization of polyesters, because they have such a huge share in textiles, and protein fibers. So I think, but there there are research projects, so to speak, really spread around the globe. So as for the recycling, where surely, as it was mentioned before by our colleague, EU may have and this is a good thing, but may have a forerunner position. I think the research that is going on is really spread across the globe, and that's something that's good, I think.
Fantastic. I have a question from the audience for you, Wolfgang. The cost of landfill in Austria, is this a driving force for a lot of the recycling?
I would say for Austria, not so much the cost. Well, it's expensive, of course, but it's mostly due to bans in landfilling. So also, it was mentioned before, there is a huge difference in approaches, even in Europe. And I don't want, again, there is nothing attached to it, but Italy, for example, has a much higher rate in landfilling still than Austria or Germany. And in Austria, it's mainly due to quite harsh rules that would apply. So for example, I know that in Austria, if you landfill something, it needs to be sanitized, and then there is a maximum allowed content of total organic carbon, if I'm not mistaken, of 0.5 weight %. So if you think that for Vienna, and this is quite low if you compare it to studies across Europe, if you have roughly 3% of textiles in municipal solid waste, which was detected in a huge campaign that was carried out a few years ago, then you would think, well, at least or already with this amount of textiles, you would exceed the 0.5%. So as we've discussed, and also my two colleagues discussed this, there need to be incentives. And one thing can be legal requirements, and the other thing can be incentives. So with us in Austria, I think it's really due to the legal requirement that's not possible. So in Austria, the thing that is now done at the moment is incineration, and then afterwards it can be landfilled. But there are different approaches, and as I feel it, it's not a good option that we solely go for incineration in that. If we can get this material back and reintroduce it into the circle.
Great. Thank you very much. I think once again, with all topics on sustainability, we come back to the central relationship between policy and technology. I'd like to open the floor to presenters if you have questions for each other. Viktoria, do you have any questions?
I think it's more just maybe continue elaborating on we've started speaking about, which and actually just ended with this, how we bring how we take this out of academia, right, and how we make this practical. I also think we heard about so many different approaches, and if the regulation, even if it only took it here up, just because, as you said, it is the phone runner in the end of the day, and everybody that is a member, of course, will have to oblige in one way or another. I think what's very interesting is really to understand, okay, what's the right approach to bring this all together? Like we have, I've presented in our presentation, we really look at the whole picture, as to say, right? Because we think that everybody needs to be part of it. I also think that, and I think we haven't mentioned it so much, is there's also the problem that we always say in our work is to say, okay, we can't be in a place where we'll maybe solve one problem, but then create another one instead, right? So what happens with like the many approaches we heard about? Can they do they also save energy? Do they save water, or maybe don't use water at all? What about the chemicals, right? So this is one approach. In the end of the day, it needs to be circular, it needs to be sustainable all the way, and also the suppliers around it, right? I know it's very complex, but I think that we must aim high. Otherwise, again, we won't make a difference. And then the other side is, and again, and I don't think we've mentioned it enough, and it's very important to emphasize that, today, let's say you were speaking about the recycled polyester and the PET and so on, and many of the recycled materials that the industry already uses. If you go into the big retailers like Zara and so on, you will see that there are a lot of collections already. It says, right, recycled PET. I won't go into the question, what about this is recycled and what not, and how much truth is, because we're not in a place yet where we can already scan the product completely, right, and get information about its whole supply chain. But the bottom line is, and again, this is how we're basing our vision on, is that we believe that the only true fulfillment of circular economy will be when the local waste will be actually the one that will be taken and then created and recreated into new materials, right? That the local industry will be able to use. This is what I frankly believe is the only way to do it. I know it's very radical because, again, there are a lot of factories today that you can order recycled materials from, but then you will have to ship them and so on. So it's a kind of just a question I would love to hear, my colleagues' comments on what they think about it.
We could pull out a single question from that. I think it would be, in what other ways do the technologies that are overviewed approach sustainability, or approach a kind of
sort of justify them maybe to go further? Yeah.
Sure. Dr. Yao, if you have an input here, really appreciate it.
I don't know how to say. Actually, I think technology still accepted the technology challenge. I think for the textile recycle, I think the logistic and the policy wise will be, we need a bigger support from that part as well. So as the EU has very clear direction and the policy to restrict the textile waste, I think Asia, still on the way. So, and I think also maybe the culture background different, the second hand or reuse, resale, such kind of activity is not so popular in Asia at this moment. So I think that will be, from my point of view, I would think in Asia, we really need to do improvement in the resale, reuse, and repurpose. So minimize whatever the process, the chemicals, the water utilization, whatever we do, the second or recycle the textiles. That's what I'm thinking. Yeah.
Understood. I think generally in sustainability, there are so many problems at every single stage, and any assessment of sustainability is essentially an assessment of opportunity cost. It's why is this alternative more sustainable than this other alternative? We have a question from a Boris Mintz Institute fellow, Ron Fishman, who was asked why is incineration not a good option? If anyone from the I think Wolfgang, yes, please take it
Yeah,
away.
I mean, I think I can go into that a little. Also, the second question, it's somehow related to that too, because there is a possibility that a future system, if we're not coordinating it on a global level, and I think this is very necessary. May look like well, okay, we did not manage, and we use incineration. Incineration is not a bad thing. That I want to put that clear. It's to my opinion, it's a much better opportunity than just landfilling everything. There can be a possibility, there can be a benefit in composting, for instance, or there could be a benefit in using cellulosic textiles to that. My guess is incineration is not the best option due to the fact that in the polymers that you produce, depending on and the garments that you produce, depending on the level of integration, you don't just put the energy of the material, you put a lot more into that. Quite fairly speaking, of course, if you use a approach that would degrade part of the polymers to monomers, of course you lose, so to speak, more energy, but you will get back the added value by being able to recover other materials. So that's basically my only saying why we should first think about recycling, and then if there is no other option, of course incineration is a viable option to that. Yeah, basically it really depends on the complexity of the textile, because obviously it makes no sense if you for recycling, if you use we are talking about that as a main criterion. If you use huge amounts of energy that would exceed the ones recoverable by incineration, and then of course this is something that you don't need to be biased about. Yeah, and maybe if I just go to the second question, I think really, and to give the others a floor too, the other speakers, I just want to mention that the future system, I think, needs to be coordinated globally. I mean, I don't know if we really reach it until 2050, but I'm sure that there will be several systems on the globe. The EU is starting with that. France started, because it was mentioned also beforehand that legal initiatives are very important, started an EPR scheme. So this is something, that's the first country that implemented this on a state level. And that's something that you wouldn't have thought about 10 years ago or 20 years ago. So I think there will be more options in recycling. The recycling technologies will be more sustainable because you would use less energy, because economy of scale, so to speak. And I'm sure it will be not only one option, there will be a bunch of options that we will need, that we will use. And several technologies, as I mentioned, the mechanical recycling, tearing lines, and extrusion lines are already implemented. So I think that's something that will be integrated. What I think will be also an issue for the future is that you would try to have more design for recycling, design for reuse in the textiles. So it would extend the collection system. And you would think about bio-based polymers, which, by the way, does not necessarily mean they're biodegradable. But this is something I think it will go in this direction. And these initiatives that we've seen today also show me that we're on the verge to do so.
Yeah, sure. Just for 1 second, the question that that Wolfgang is asking is, if they had to make a best guess, what would textile waste handling look like in 2050? Victoria, please.
Yeah, actually, well, it kind of also refers to the previous question about incineration. I do want to mention 2 points. First of all, we must remember what we're currently dealing with. We're dealing with, and we're looking especially at post-consumer textiles, which are much harder, of course, to treat than post-industrial because they're much more homogenic. Post-consumer comes mainly from fast fashion, from very, very low quality fibers and materials, which means that the intoxication level is probably also much higher, right? I mean, even the cotton, when it says it's cotton, we don't know really exactly what kind of cotton it is, what kind of chemicals have been used to dye it, and so on. So we have to consider that problem. And the other thing, and I'm kind of following, Wolfgang's, statement that it's really not about finger pointing, but I'm not sure I would want to trust every country with the incineration process. I'm sorry to say that, but it's when we're looking at and we spoke about this so much throughout this panel about the diversities and the differences and how the recycling is being treated. Ultimately, incineration, you really have to, if people want to know more about it, look at like some countries, and especially Scandinavia, are really doing it right. But again, they have created the facilities. They might also even have the geographical and possibilities for that, but not every country has that. And I don't think we want to be experiencing that. So that basically, I know we're almost finishing. So kind of also summarizing maybe also to the second question, you said it, you saw it in our video. Research shows that even if we stop producing garments now, we would have to have enough another 50 years. So we still have those huge amounts we have to actually find a solution for. Not even to mention COVID, which of course left the industry with huge amounts of stock, which also needs to find some kind of an outlet. So what we need to start from is really remember that the amounts are really huge, they're enormous. I know we heard that, I think in Vienna, they found that it was 3%, which was part of the municipal solid waste, which went to textiles. Well, the EPA, the Environment Protection Agency of the US, actually showed that it's in the US, it's about 9.7%, which goes to textiles. So, I mean, and I assume that the more, given that textiles are rising, we're buying more, overconsumption is still out there. So the numbers will be increasing. Also, the better research we'll do, the more we'll find, of course, the more, separate textiles. So the only solution is really to continue understanding and creating awareness about this problem, taking it out of the niche that it is. And also one more thing to consider is that I think that there's no bigger gap between, as we call it, the beautiful side, the bling bling side, the glamorous side, and the really ugly side of the industry. The fashion industry invests so much money into showing the beautiful side of it that it really takes away from the waste problem. So we must continue bringing together all the stakeholders to one table and really get them to be willing to collaborate with us, to continue doing the research, and be part of course, creating the solutions for that too.
Yeah. So in the future, more partnerships with the bling bling, flashy
Absolutely.
end of fashion for sure.
Absolutely.
Dr. Yao, finally from you, what do you think the textile recycling industry will look like in 2050?
Yeah, in my imagination, I think it will be some smart system. I like the topic as the selective depolymerization, and maybe is a selective depolymerization plus repolymerization. So we can have some universal method can redepolymerize all the polymer we have done, whatever used in textile or other industry. And then we can repolymerize them to fresh, high quality as the virgin quality fiber or material. So that's what I'm looking for. Thank you.
Thank you very much. I've got a question for all three presenters. I admit you might want to take more time to answer this, but I think it would work well as a short answer too. Sorting and separation are fundamental challenges for textile recycling, but all textile recycling is recycling material that comes from a feedstock, and that feedstock is based on the materials that are demanded in the first place. If you change the materials that are demanded, you change the recycling processes that are required downstream. A lot of the challenges in recycling processes, not just the process themselves, but the sorting and the separation, have to do with the removal of certain materials that just don't fit into the recycling processes. So if you could choose one material, just one, to remove from the whole stream, from the whole waste stream, which would it be? Wolfgang, I'm going to pick on you. You
Okay,
first.
so I could choose a bunch, but at the same time, I know several of those are needed. If a quite obvious thing is spandex or elastane in cotton trousers, for example. But I think this is something that we will be able to deal with in the future. So I'm rather more towards chromium or antimony or heavy metals in flame retardants. That's something that really needs to be dealt with, because in a very low concentration, this can impose huge problems. So I would go to that.
Both ecologically and for human health as well.
Exactly.
Dr. Yao, if you could remove a single material.
I'm thinking I don't aware the spandex, and I will go agree with Wolfgang. So the harmful chemical treatment actually, and the binder, that's what I would like to remove. Yeah.
Sure. Understood. Sure.
I'll keep it even more general. I mean, again, the world has realized that we have a plastic problem, and but most people are not aware of it, that 60% of our textiles are plastic in the end of the day. So we must tackle that problem, because otherwise we'll continue having not just the problems of recycling, the health problems. I truly believe that there is a strong connection between, health problems, of course, environmental impact all over, if we'll continue using those ultimately plastic-based materials. So I really hope that this is going to change. And if I can say just one more sentence, also kind of speaking about the vision, I also really hope that, the fashion industry will just really start looking, and also as consumers, at clothing from a very different perspective. There used to be a time when people were wearing, of course, much more natural materials, and there was no need for something else, and then it worked. Also, we might also need to look into something which is more customized, or let's say, is not all of the same. We're used to seeing clothes in mass production, right? All of the same, and it would look weird to us today if something looks different. But if we want to go into the upcycling streams and want to create more of that, then we might find that collections and garments will look different one from another, and that should be fine. I really, really hope that this is going to become just a regular, picture in the industry, in the stores, and in the awareness of the consumers.
Thank you very much. Absolutely wonderful. That is our time for our first session. Thank you very much to all the presenters and to everyone in the audience. We will be rejoining in 1 hour for our session on energy, joined by some fairly high-profile speakers. That runs from 12 till 2. We have another session running from 3 till 5 on on-site Greywater treatment. And thank you very much. We're going to pause the Zoom now and re-begin in about an hour.
Thank you.
Thank you. Thank you. Bye.
Okay. Welcome back to the RISE discussions number 1. This is our second session where we'll be talking about urban energy generation. Our first session was mostly focused on textiles waste recycling. This session will be on urban energy regeneration. We're here to challenge the paradigm of energy generation taking place outside of a city and energy demand taking place inside a city, and what technologies and policies we can suggest to challenge that paradigm. Our first speaker is Yoni Haran, who is right here with me, who will be presenting on Sustainable, the Village in a Box solution. Yoni, take it away.
Thank you very much. I'm very happy to be here. Let me just share my screen. You know, if you can see it. So I'm a CEO of Village in a Box. We deal with smart infrastructure. I'm a mechanical engineer. I studied here at Tel Aviv University 10 years ago. Former CEO of Engineers Without Borders Israel, expert in waste to energy, dealing with a lot of infrastructure projects, and very happy to be here talking about the future of infrastructure and future of energy and sustainability in cities. So billions of people in the developing world lack access to infrastructure. What you see here is a picture of our Earth at night, showing those places where we don't have electricity. You probably know this picture, but electricity is not the only story here. 1 billion people lack access to electricity, 2.4 billion people lack access to sanitation, 600 million to water security, 800 million to food security. Big problem. And why? Because it's not economical to deploy the old infrastructure to those locations. I'm talking about cables and pipes, so they just remain unconnected. Okay, and climate change is making this problem even worse. Okay, with droughts, with water security, food security. Governments understand this is a big, big problem, and they spend a lot of money in trying to find solutions to make communities climate ready, to make them resilient to climate change, or to mitigate climate change itself. You can see the money flowing from developed countries to developing countries, about $100 billion a year. Quite a big problem. So what solutions exist? Great decentralized infrastructure solutions. For water from air generation. We have microgrids supplying off-grid energy from renewable energy sources, wastewater treatment in a box in containers, climate-controlled food tech solutions. All are great, but the problem with them that they only supply one vertical. Okay, when in every human community, we always need all of them together. Okay, so it's a big problem. So comes the question, can we combine them together so they will work better? Yes, of course. In fact, when we look at the data, they work better, more resilient, and more profit. They're connected together in circular economy business models because they have synergies between them. They have natural synergies that unleash and make them more profitable. And it's not a secret, it's no surprise because in nature, everything is connected. The term which best describes this is the water, energy, food nexus. It measures the connection between the systems. It's a great indicator for profitability, for resilience, for efficiency. And what we want to do in Village in a Box, what we're doing is taking inspiration from nature and redesigning the infrastructure system that will be synergy-oriented, profit-oriented, resilience-oriented, and climate-oriented. So our solution is Village in a Box. It's a self-sustained infrastructure grid that supplies all basic human needs to communities self-sufficiently, independently, supplying water, energy, food, sanitation, and basically the whole community becomes a circular closed-loop entity which recycles everything, completely powered by waste and by renewable energy. What you can see down here below is our product. It's a box the size of a few houses, and the rest of the community can be completely off-grid. Works very well. So what is our technology? It's an integration of commercial technologies that are equipped in these containers that you see here. We upgrade some of the containers so we can unleash those natural synergies that exist between the systems. And the containers are connected to each other, feeding each other in a closed loop system so they can work better together. Okay, you see here many systems. The agricultural solutions can connect to existing solutions or can supply others from existing companies. The main product is what you see in the center. Let's see how it works. A very interesting video. So what we see here is the wastewater flowing into our system, into three valuable resources. One of them is the water that is purified and then sent to irrigation, into existing systems, agricultural systems. Second one is converted into biogas, a renewable fuel, which is converted into heat and power, electricity. And the third is fertilizer, which is also sent to the greenhouses to increase the yield. Organic waste is also grinded in the kitchen waste and also sent to the system. And then the water is sent back to flushing toilets. So we save a lot of money in water. We get more energy security from this organic waste. And if we're talking about a municipality, it can save about 50% of its landfilling cost because everything is recycled on the spot. And this is just the beginning. This is just the basics. We're talking about circular economy for cities based on the basics of infrastructure. When everything works right in the infrastructure, you can develop more layers that are built upon that. So our focus currently is the developing world because we see there are big needs. And here you can see our village in a box deployed in 2 locations. One is a refugee camp and one is an off-grid village. Basically, it can be shipped and deployed very fast anywhere. Can be with wires or wireless, depending on the structure. And it transforms every community to be climate ready, to be more efficient, to be more resilient, and to be profitable, to make money out of its own resources, things that they use every day. So let's talk a little bit about our competition. One of the main competition is the microgrid market. Microgrid is a way of supplying energy from renewable sources in an off-grid way, mainly solar and battery combined together, okay? It's a big market, about $47 billion in 2025, but it has its challenges, okay? 3 main challenges: stability, high energy cost, and storage, and also pollution. So you can see on the right-hand side graph, a graph that shows how the price of energy changes with the amount of energy we consume. The less energy we consume, the higher the energy is. The more energy we consume, like in the blue dark, $35 per kilowatt hour, comparing to $55 per kilowatt hour, very high energy cost, and it's a big barrier for development. The second thing is diesel. Sometimes we use diesel engines to power those microgrids, to give it extra power in those cloudy days. The energy prices become sensitive to gas prices. It's very pollutive. It's a big problem. And the third thing is storage. Storage is expensive, a little bit pollutive, and you cannot put how much storage you want, so it affects also the prices of energy. So we can summarize and say that microgrids work effectively only when they're utilized until the end, all the way. If you don't have enough consumption for it, it will not work well and the energy will be very expensive. So how we are solving this? Everything is a battery. Battery is not just lithium-ion batteries, which is very expensive. Batteries is a lot of things. Let's take a look at the cycle of flow of streams that we have here. So we have, I see here myself duplicate. Thank you. You can go outside if it doesn't work. So how do we generate energy? You can see here we have 2 main ways. Can you see my mouse? No. So 2 main ways to generate electricity. One from the sun, about 2/3 of the energy we produce from the sun, and we can store it as electricity. You can see the small icon of battery. But another way we produce energy is from our waste. The difference is that when you convert organic waste into energy, it's called biogas, you can store it also as energy, which can be stored for 3 months. it's much a longer cycle, and it's much cheaper also. So together, when they work together, we get a lower price of energy. Layer number one. Layer number two, we don't have to supply all of the energy only in a form of electricity, okay? About half of the consumption of our domestic use is thermal energy, cold and heat changing in the summer and the winter. And once we have excess energy from renewable energy, why don't we use it to store excess heat for later or excess cold for later if we know we will use it, right? Why do we want to do it? Because it's much cheaper, okay? It's about 5 times cheaper than the price of batteries. So this is the second layer. We diversify the storage and we really save on cost, okay? So we look at everything as a battery. What about the upper side of the circle? We see systems that treat the wastewater, make fertilizer, all kinds of systems that are very energy intensive. They work stupidly when they want. When we can hack into their systems and decide for them when to work according to their constraints, we use them as a virtual battery, okay? And we maximize the energy use. We don't need to store when we can shift when we use them. So every system in our village in a box system is completely considered as a battery. So we have more storage at a lower cost. How do we deal with this on an intelligent way? So we have our software, which we developed. It's an AI software. Basically what it does, it creates predictions. Prediction to the consumption of energy, consumption of water, all of those things. We know how it will look like in the 24 hours, according to patterns of users, clients. On the other hand, we know what will be the weather like, and then we can predict our generation. And we know how much energy we have in our battery. Now we have to regulate between them and say how we can allocate enough energy for each one and resources for each one to keep the lowest price. Currently, this saves a lot of money. Comparing to microgrids, about 50% reduction in cost. Comparing to infrastructure in existing cities, about 30%. So it's very efficient. We won a grant from that, from the Israeli Innovation Authority for breakthrough technology. We validated our information with the one municipality in the south of Israel, showing 94% of prediction rate. So there's a lot more to go from there. So just to summarize our advantages: lower energy, lower cost of storage, more energy produced from the same resources, lower cost of building, more clients, more revenue streams, and more reliability. Basically, disrupting the infrastructure, much, much better model for every community. Of course, the main why we're here. So zero carbon is completely without any emissions, very clean, very sustainable. So it also protects from climate change, but it also mitigates. So how do we make money? Our focus is on lean manufacturing process. What we want to do is execute as many projects as we can in the short time. So we prefabricate the infrastructure in the assembly line. We don't do it on site like nowadays projects take a lot of time and delay. We do it off-site. We send it, we install it very fast, high quality. It allows us to do many projects. So the second thing, once we install it, we sell it to governments, we sell it to aid agencies. It can serve up to 5,000 people, and this version costs about $7 million. Okay. We're installing it with our partners, Global Siemens, EPC contractor, giving us the financial back, engineering back, and great support. And once it's installed, it's controlled via our software, which manages everything, remote support, and we use a local operation and maintenance partner, which supports us. All kinds of other great solutions like telepresence solutions, like other stuff that allows you to be there without actually being there, and saving a lot of money and creating a lot of value for customers on site. So let's talk a little bit about our projects. Our first pilot project is with our partner, the Arava Institute for Environmental Studies. It's in the south of Israel, a very arid area. And they're building a new campus. So they want their campus to be sustainable. They want it to be climate ready. And we're supplying the infrastructure for that. Starting, let's take a look, beautiful architecture, by the way, by a gas architect. So what you see on the left-hand side, next to the solar field, is our system. Not so big, the size of 1.5 buildings, and it will be connected at first to the building that is closest to it, and supply for 32 students all of the infrastructure. Those students will live like in a living lab, researching it, giving us feedback, developing all kinds of features. And after 1 year, we can validate all of our economic assumptions, engineering assumptions, and from there continue to support all of this wonderful campus. So, by the way, one problem that exists in Israel is that you cannot sell energy to the grid nowadays in the south and not in the north due to regulation problems. They don't have enough capacity in the power lines. Okay, some places it will take only 3 years, some places only 7 years, only. And what it causes an effect of an off-grid movement. Why do we need those lagging government authorities when we can provide for ourselves and be sustainable at the same time and be profitable? So lots of kibbutzim are starting to think about this, and Torah was always a pioneer in sustainability, so it's a great partner. Yeah. So, short list of all of our partners, technology partners, industry backers, organizations. We believe in corporations. So far, we won 2 grants totaling $500,000. We won a few competitions. We have a commercial MOU with the city of Mitzpe Ramon. Lots of interest in this field, really, really hot topic currently. And I believe this is the holy grail of sustainability. So thank you very much. I'm happy to answer any questions.
Okay, thank you very much, Yoni. A really excellent presentation on the way in which different technologies can be combined intelligently. In challenging the paradigm of energy generation outside of cities and for innovative ways to integrate a series of different technologies. There are lots of technologies being developed at Tel Aviv University. There is an energy generation center, a research center here. One of those pieces of research is being conducted in the Porter School of Environmental Studies in the group of Alexander Goldberg. Our next speaker, Maya Mosseri, is a researcher in that space. Yes, that's possible. I'll just share the screen now. Maya, show. Share the screen.
Thank you very much.
Thank you very much. We will be doing a discussion, a panel discussion, for which questions directed at you, Yoni,
Great.
will be coming. No, you can sit over here. You can join the panel in a second.
Thank you.
Good afternoon. My name is Maya. I'm from the Porter School of the Environmental Studies, and I would like to present today a new process that we are developing about the energy utilization based on municipal organic waste. A little bit statistics of the municipal solid waste in Israel. It's about average waste of 1.76 kilograms per capita per day of waste, while total annual waste is about 5.8 billions of tons. From that, 80% is produced by households sector, and 20% is about from the commercial institutional sector. The growth of the waste in Israel is about 2.6% per year, and about 80% of the total waste produced in Israel is buried in landfills. As you can see, Israel is much higher at the average of the waste, about 30% compared to the OECD countries. What is the path of the waste in Israel? Starting from the neighborhood, it transfers by truck to a waste sorting transit station. And at this point, it's sorted to several streams. One of them is recycling. As you can see, it includes glasses, cartons, paper, and different plastics and metals. Another one is the wet waste. While the sorting of this stream is quite poor, it includes parts that are non-organic, and the reason that it couldn't be selected because the limitation of the sorting machinery at the sorting station. So the very huge part of the organic waste goes to landfill, as mentioned before. A very small part of it are used for the RDF plants. The part that has been the wet waste that has been selected is partly goes to the composting site or anaerobic digestion site. This is the percentage of all these parts that I mentioned before. The landfill, as you see, is about 80%, while recycling is 40%. All the others are much smaller. Okay, what are the landfill costs? First of all, there are direct costs as landfill pollution, water pollution, and direct air pollution, about 4.7% of the all GHG pollutions in Israel. And of course, the cost of the land that cannot be used after that. And another, of course, indirect costs as transportation costs and fuels and air pollution, GHG and traffic load and accidents, of course. What are the difficulties in the current waste management? There are, as I mentioned before, environmental and economical process of truck-based waste transfer. Current regulations do not encourage to reduce the landfill, so not really there's a reason to change it. And as I mentioned, the limited ability of the sorting machines causes poor separation and leads to overload the landfills with pollutions. And law enforcement and low fines allow to continue environmental damage. So we are looking for solutions, environmental solutions for the organic waste. Our research is looking for environmental on-site solutions. For this waste, it will reduce, on-site it means on the sorting station place, while the waste is being transferred from the neighborhood at the same point. So this will reduce the volume of the waste, the scope of the landfill, and the need to use the trucks to transfer it to landfills, of course, and all the side effects of that. Furthermore, it will produce an economic and energetic value of the products of our process that we are dealing with. It includes biocrude that can be upgraded to fuel, and biochar that can be used as a source of energy too. What is the HCl process? HCl process refers to hydrothermal liquefaction that based on decomposing the waste by using compressed high pressure water. We are talking about the sub-critical point of the water, and in this way we are produce biocrude and biochar, and that are energetic value products. What are the advantages of this technology? First of all, we don't need a pre-treatment because we can use a wet waste. It's very important because we don't need extra energy to dry it, as in other technologies. We got a high throughput and a high energy and separation efficiency. We can use a mixed feedstock as the waste is, and we can get products of biofuels. Okay, the disadvantages is that this kind of technology is it's quite complicated because we cannot really characterize the reaction pathways and the kinetics of this process. The product that we get, we need to upgrade. It's not really immediately can be used, so it needs more energy and more processing to use it. Okay, so let's see what food waste is composed of. First of all, the food waste is by its nature is heterogeneous mixture and very difficult to characterize it. It has organic and inorganic ingredients, and the organic part cannot be measurable and fully measurable. There are parts that we can recognize and measure them, but there are parts that we cannot recognize. For example, soup. Yeah, okay. So we need to, for our process, we need somehow to define what is the waste made of. We based our simulation of waste on a survey that checked what is waste consists of in 192 families during one full week. And we based the results, we based our combination of the simulation food waste on that results. The results shown that 48% of the food of the municipal waste is consist of organic part, but just 35% of it could be recognized and measured. This slide explains what is made of the part that was recognizable, and again, it's based on a real data from a real waste of families. This proportion of the food waste was the base of our mixture. Then we took samples of this mixture and we proceeded different HCl processes with different conditions. We can see here tubes which includes, as you see, a dark part that is the biocrude, biochar, and the liquid phase, the yellow one. And we separated it and dried it and checked the quality of the products. We are looking for, first of all, to find how we can represent better a simulation of food waste, since, as I mentioned before, we cannot fully define it. We're planning to move to continuous HDL experiments. It means a different approach, much more suitable for industry. And our aim to use the real waste finally, despite objective difficulties such as risk from pathogens, and we're looking how to do that. The potential for Israel and other countries. Israel is a small country, so we have land reserves, very low land reserves, and we need to find a solution to reduce the need of landfilling. Okay, the potential of the waste treatment using HKRITA process can reduce the need of landfilling, as I mentioned, and the side effects. And the on-site treatment of the sorting stations can be a good way to reduce it. And okay. Okay, I want to thank my supervisors, Professor Goldberg and Professor Gozin, and Mr. Epstein, who contributes to my vast experiment, from his vast experiments. Thank you.
Brilliant. Thank you very much.
Okay.
Whilst we're waiting for our next speaker, we have a couple questions.
Okay.
Just quite quickly. The production of biocrude is an essential part of the HDL process. Does biocrude work as a transitional fuel source? Because we currently use fossil fuels. In the future, we might use fully renewable energy.
We need to do some upgrading for that, but it's actually an energetic product, yes. With quite high caloric value. And we need to do analysis for that product, but it's already fueled.
So the production of essentially a crude oil analog from municipal waste represents a stepping stone, using conventional technology to something that's a little bit more sustainable.
Yes.
Okay. The second question was, does this technology, does HDL, does it work better as a centralized system, or does it work better if there are lots of small systems, if it's decentralized?
No, it can be decentralized because it depends of the volume that you want to proceed, of course, but it's possible to, first of all, we need to find out that it's really economic worth to do that, and to make a proof that it's really the right way to do that, but we can upgrade it for bigger, and depends on the volume of the process.
I suppose it's just does the efficiency increase or decrease as the size of the reactor gets bigger?
It's a little bit too early to answer for that, but of course it should be proof that it's worth energetic and economically and energetically, yes.
Thank you very much. Okay. Wonderful. We're going to move on to our next speaker. Boaz, are you connecting? Whilst Boaz sets up, a couple words about the RISE organization, the RISE Lab. This is a series of discussions, conferences that are happening here at Tel Aviv University. But the RISE Lab itself is named for Radical Innovations for a Sustainable Economy, is a lab that we're building here at Tel Aviv University that is based around a series of technologies that we can use to bring us closer towards that circular economy. In particular, we have projects ranging from on-site greywater treatment, which is actually the focus of our next session, and a series of other waste treatment technologies, which was also the focus of our first session. So in many ways, the RISE Lab, the Radical Innovations for a Sustainable Economy Lab, will be based around the urban sustainability topics that we're hearing about today. ready?
Just a technical thing. Is this port working? It's not reading my
Yeah, I think so.
drive.
It's not reading at all. If you could use your computer, just use currently signed in as a co-host, then you could.
Where is it?
That's over there. We're having some technical difficulties. I'm sure we will be with you in a minute. Good. There we go. Wonderful. Moaz is the head of the Office for Sustainability of the Municipality of Tel Aviv-Yafo, and is widely respected as a voice on heat islands, energy regenerations, and all things urban sustainability. Take it away.
Thanks. So, thank you, Eitan, for the introduction. My name is Boaz Kedar. I'm the head of Sustainable Planning and Energy Department at the Engineering Administration at the Tel Aviv-Yafo Municipality. We good? Oh, it's this one? And great, thanks. So I've been asked to speak about energy generation in the city. And I want to show you some of the directions or efforts that we're undertaking at the Tel Aviv municipality, and show you where we're headed and where we're coming from. So this is where we're coming from. We're coming from a place that I assume all of us know, and I assume I'm preaching to the converted, but we've had, the past few years have been the hottest on record, and we've had record levels of parts per million of CO2 in the atmosphere. And we know that cities are actually in the front lines of both the climate crisis, the energy crisis, and the third crisis, which is intertwined, which is ecological system decline. And if I take this down a notch and ask myself what this means to us as people living in Tel Aviv, the country's largest metropolitan, which is home to almost 500,000 inhabitants. And by the way, anybody know how many people commute to Tel Aviv daily? So what is the city's population during the day? It's between 250,000 and 300,000. So not all the inhabitants stay in the city, obviously, but the city grows and expands with every workday, and all this human activity leads to further development, a lot of construction, and we know that this human activity is taking a toll on natural systems, coupled with the projections for temperature increase with all its offshoots. I want to introduce a term that I assume some of you know, but I'm an architect and planner, and this is where I'm coming from. The heat island effect is what we call a phenomenon which is relatively new. It was identified and isolated in the 1980s, I think late 80s. It's actually very simple. It states that an urban area actually experiences a temperature increase both in the daytime, but mostly at nighttime, because of the city's hardscape. The city has a lot of materials which are non-porous, have a really high heat retention capacity, pavement, asphalt, concrete. And as you can see in the illustration, if I compare the city area to a parallel area in the same climatic zone, which is open, I'm not even talking about a vegetated area. If I'm talking about, let's say, if I go about 20 kilometers south of Tel Aviv, along the coast, so same climatic area, the heat that comes down, that is projected down, the sun's radiation is dispersed or reflected, and some of it is absorbed. But
in the city, the portion that's absorbed is much larger, and we see that heat being sent back out to the environment when the sun sets, when the sun goes down. So I can experience anywhere from 3 to 6 degrees Fahrenheit, which is higher during nighttime. These are some thermal images, just one screenshot out of a very long research that we had carried out by the Goddard Institute for Climatic Research in New York City. This is what you see. By the way, anecdote. Who knows what this is? It's very close to where we're sitting. I wish I could zoom in. It's actually a large soccer stadium just southwest of where we're sitting, but it's all artificial turf, plastic grass, which you know really retains the heat and reflects it. So if we're thinking about a phenomenon like this, and coupled with the data that we have from NASA, we can experience up to 3 months of extra hot days during the year. This is on top of what we have now. So instead of summer being, you know, June, July, August, or June, July, August, September, imagine the summer would start sometime in May and would carry on further into the holidays to around October, even November. I usually show this presentation to professionals in the municipality, you know, people who have nothing to do with climate or energy. The graph is a little wonky, it goes right to left, but if you see that only 10 years ago, this graph shows how many months out of the year we irrigate the city's green spaces. So a decade ago, it was 6 months out of the year. By the way, 2019, 20, and 2019 and 2020 aren't on the graph, but this last year, we were still watering, we were still irrigating in December. So 12 months out of the year. A little word about what we call energetic poverty. Energetic poverty is a term usually associated with people of lower socioeconomic status who don't have the means to climatize the places where they live or work. This is typically elderly, homebound, handicapped, or just generally poor people. So taking all that into consideration, last summer, Tel Aviv launched an action plan for climate adaptation. We're the only local government in the country to have done so. I think we're the only one in the Middle East. I'm not sure. Maybe Cairo has one, but it doesn't really matter. What matters is to remember these 3 vectors. Climate is constantly changing, coupled with continued development and construction. And in the background of that, you have an ecological system that's in constant decline and erosion. I'm going to share. This is the last slide, which has sort of figures on it. But this is what Mayor Huldai committed to on stage in Copenhagen in the last series of climate talks with C40 cities. I'll explain about them a bit later. I want to draw your attention to the second line from the top. At the moment we have about 4% of the city's energy, cities and electricity comes from renewable resources, and by 2030 we want to take that up to 100%. It's quite ambitious. I'll show you how we're going to do that. So I mentioned the name C40. C40 is an organization that Tel Aviv is a part of. It's part of the European Union. It's actually a consortium of almost 100 cities, some of them many times larger than Tel Aviv, that all underline their efforts or their joint efforts to uphold the IPCC's guidelines and to dramatically curb carbon emissions in cities. So the subtext here is we're not going to wait for the politicians. We're not going to wait for the governments. We have to take matters into our own hands because we're practical, because we're local, we're smaller, we're more agile, and we know our population. Energy. I don't have to say anything, right? It's from this to that. We want to, and I know I won't talk about the strategy of the country's strategy of energy production, because it's grounded in many decades of war, and every decade. When I was born in 1972, when I was a year old, my father went out to fight in the Yom Kippur War. Every decade, we had a war, more or less. That's something that sort of set the tone for the city's strategy in many fields. One of them is energy production. So Israel, energy-wise, is an island. You know, we can't, if we have a peak in our demand, we can't, we don't enjoy the purchase agreements that cities in Europe or states in the US enjoy. It's all contained. We have to be like sort of an autarkic household, or so we've identified these four sort of streams on the left. From the top is maximize solar production as much as we can. The second is energy from energy generation from waves. We had a very nice pilot in the Jaffa port. It's moved from Jaffa port to somewhere in Gibraltar. It's a young woman with a company called EcoWave. It's a startup. She had this idea. She's a mechanical engineer. I won't go into it, but it was nice as a pilot. It's not something which is feasible to have a substantial impact on the city's energy production, but maybe on a national scale, it's something worth considering. The third from the top is something where Israel is in very, very much behind on. It's energy storage, grid level, national level, local level, and micro level. Micro level means that in every condominium, every binyan dirot, I will have, like I have the little room for, I have the lobby and the little room for the bicycles and the little room for the trash containers. I'm going to have another room which is either going to have a micro turbine generating energy and heat through a combined cycle running on natural gas, or I'm going to have a storage system, a battery storage system, which can hold enough battery to bridge some gaps of peaks. The peaks, by the way, in Israel are usually two. In the winter time, they're usually between 4 p.m. or 5 p.m. and 10 p.m. when everyone goes home from either school or work, and everyone's at home and all the appliances are running. The second peak is midday in the summer months when everyone, no matter where you are, flicks on the air conditioning. So I'll tell you where we're headed in that sense. So this is just to give you an idea of how many cities around the world are taking this challenge head on and tackling or drawing citywide master plans for energy management. Funny enough, there is not one city in Israel which has an energy master plan. This is due to centralized production and distribution. But Tel Aviv is writing one now. I hope that by the second quarter of 2022, we can publish it. It's actually going to cover mainly two topics, or mainly two strategies. On the right, maximize energy efficiency. On the left, maximize clean energy production. I'm going to go into a little bit of detail on both of these, and then open it up for questions. So I'm sorry the PowerPoint is in Hebrew. I didn't have a whole lot of time to prepare, but mostly our pathways are actually three. So it's the green is efficiency, the blue is production, and the yellow is energy management. And you can see, for those of you who read Hebrew, the energy efficiency is, these are just bullet points, but green building standards, which are mandatory in Tel Aviv as of 2016. We're taking them up a notch a little bit every year. Net zero buildings, which we have the first pilot of. It's not the first in the country, but it's the first of its size in the country. It's a kindergarten. It's a multi-story kindergarten of 8 kindergarten classes in 4 stories. In Tel Aviv, the space is really limited. Public lots are very tight, and we build our kindergartens in stories, in like a mini high-rise. So this is the first one. We have Shiputzim Yerukim, is actually green retrofits, and LED lighting of all the public lighting is already something that's underway. We have out of about 80,000 light poles in the city, about a third have been converted from mercury or metal halide to LED lighting, which is a fraction of the cost, and they can be dimmed and they can be controlled by all the way up to a single pole. So all of these are already underway. The middle, I spoke a little bit about solar energy. I'm going to show you examples in a minute. Sea wave generation, tri-generation. I'm going to speak a little bit about that too. It's natural gas, a combined cooling and heating and energy generation from natural gas. And the management is usually the overlooked stream when talking about energy efficiency or generation. So it turns out you can save anywhere from 5 to 15% by just managing the way you use energy and shaving the peak loads and setting the time schedules in a way that can lead to a real much smarter use. This is just one snapshot from the our pathway, our work with Arup Engineering and C40. I'm going to talk about these. So PV on rooftops, PV on shading devices, and PV in facades. So rooftops. By the way, on the very left is the building where I work. You can actually see the window of my office is right about there. It's in Rehov Filon in Tel Aviv, not far from the beach and not far from Rabin Square. This is a nice size system. It's about 53 kilowatt peak with a footprint of about just under 300 meters, square meters. Altogether, we have over 50 such rooftop systems in the city as we speak. We roll out about a new one roughly about every month. And we're going to hopefully double that figure so we're going to have over 90 rooftop systems probably this time next year or end of summer next year. Altogether, it's 3.2 megawatt peak installed. When we mapped out the rooftops of Tel Aviv, this is residential, commercial, and public building. We can get all the way up to 80 megawatt peak. Something which needs to be kept in mind. I know the picture, the photo is showing a roof that's not in use. A lot of the rooftops, mostly of the older buildings, do have uses. Some of them are just recreational, the person who lives on the very top floor, although this is a common area, legally speaking, they will build themselves like a little hangout area, or they will use it for laundry, or they'll use it for water heating, which is part of the building code in the country. But still, we know that if we tackle this, and if we tackle the regulatory barriers, because you need all the tenants to agree to place a rooftop system on because it's a common area. By the way, just a few months ago, the 100% tenant agreement went down to 66%, so 2/3. So that's already something to our favor. But we've actually modeled the entire city. This is a nice research by Professor Aviatar Arel from the Ben Gurion University in Be'er Sheva. So he modeled the entire city to extract the potential for solar use, both on building facades and building rooftops. And if you look at the numbers, just look at this column on the left. So the building typology is on the right. The part of the rooftop calculated within the potential is on the very left. And if you see how much of the demand that stands for, you can see that a typical 4-story H building, which is a typical building in the city, can supply more than 100% of the energy needs of the tenants in the building. Just something to think about. So as of today, if you're going to construct a new building in the city, mostly a high-rise, you're obligated to construct either a solar roof or a solar facade or both, which will take care of a set percentage of your building's energy demand. This is something new. We just rolled it out a few months ago, and I can count, there's maybe a dozen or maybe 15 buildings that have already submitted their paperwork for permits, and they're going to carry out this new buildings. This is new buildings. Tell me about it. Yeah. So just a little summary, and before I conclude, something to keep in mind. Another pathway we're going in is shading of sports courts in public lots. So there are over 100 schools in the city, depending on what you count as a school. Almost all, no, there are more. Almost all of them have sports courts or open courtyards for the kids. It's actually code from the Ministry of Education says you have to have an X amount of open space meters per child so the kids can play ball and run around in recess and what have you. Most of these open courtyards are not shaded. So the kids are suffering from the sun in the summer, and when it's raining, they can't use them. So we're just now rolling out a big plan where the city will pay for shading of these areas, and the solar systems on top are actually going to finance these sheds. None of them look like this. These are all kind of bad examples. None of them are going to look like. By the way, this one is I just put one which is on a rooftop, but this is actually a basketball court. This is in Phnom Penh in Cambodia, of all places, which is a surprisingly dense city. All the others are from Israel, but they're not kind of, this is not what we're aiming for. We're going to make something which is suitable for Tel Aviv aesthetically, and something that looks a little better. I'm just going to run through the rest because I think we spoke about almost all of it. Just a word about natural gas, because it's a hot topic and it's a hot potato and it's been in the news. So the country's strategy, Department of Energy and Reshut HaChashmal actually decided to implement a nationwide infrastructure for natural gas for powering mostly very large campuses or industrial areas. In Tel Aviv, we have several of those. Two of those in the city. One is Ichilov Hospital. The second is the HKRITA, the big headquarters of the army in the center of town. Both of those have energy centers which are in great need of efficiency measures. So these two are already happening. I don't know if there will be any more or how large they will be, but in any case, I don't see a scenario where We have energy generation on a micro level for a building level, like you have in, for example, Germany or Austria or Norway. This, as far as I can tell, this is only going to be implemented in large campuses where it's regulated and the fumes are filtered and regulated and so on and so forth. And I can't talk about natural gas without talking about this type of natural gas, which Yoni also talked about. This is a system by an Israeli company. It's no longer a startup. It started as a startup called Home Biogas. I have a home system in my house where we throw all our kitchen waste in and we get cooking gas. It's about the size of like a mini car. But you stick it someplace in the yard where it's not in the way, and it's on-site energy generation from waste that would have otherwise gone to the green bin, or in my case to a compost heap. But this is a photo of actually a system that's not commercial yet, but it's a building scale system, which means if you have a high rise of 12 stories, 15 stories with anywhere between, I don't know, 20 to 30 apartments, and you get everyone to throw their organic waste in, you either do it through the managing company or you just really educate the people and hope, you know, that at least half of them will do it. You get free cooking gas. It's odorless, it's great, it's on all the time, it's terrific. We're gonna roll out systems like this as mandatory for some of the buildings, or for small industrial kitchens, like the kitchen of let's say, I know the Google offices on Igal Alon, they have 29 stories in one building. Each of those has its own little kitchen, and it has one central kitchen. So if I, as a local regulator, can enforce a system like this, I'm hoping that this will start like a wave of people who will want to do this, not because they're obligated to, but because they see the benefit. Yeah, I spoke about this. Just a final word, if we're talking about the city and energy, Forum HaChameshesre, which is the forum of the 15 independent cities in Israel, which Tel Aviv is a part of, initiated a Clean Energy Cities Forum. And all the cities that you see here, Ramat Gan, Be'er Sheva, and Haifa, and Ashdod, and Hadera, all those are members of this forum. And I really hope that if we take what I showed you today, just these snippets on the tip of the fork, as we say, and make them the standard, then we can talk about, you know, hope of meeting the city's energy needs in smarter and cleaner ways. So I'm finishing with this slide. This is actually a photoshopped slide. It's quite old. It's before, it's when Bibi was still in power. But just imagine if our politicians would put the climate first and really look ahead and think about our future and our kids' future. I think we have a shot. Thanks very much.
Great.
Oh, sit.
Yeah, please sit.
Okay.
Thank you very much. I feel like that was the beginning of a stump speech. You might continue as a politician. We didn't have a question and answer session after each of the speakers because we think a question and answer session is better done as a discussion panel. Yoni and Maya, if you would like to join us on the panel here, we have a series of questions, both from the audience here and on Zoom to yourselves, and also from yourselves to yourselves. I'm sure you have many questions for each other. No, here. So, for a series of questions, Yoni, you mentioned the synergies between different processes that are contained within the village-in-a-box system. Can you elaborate on some of those synergies, what they mean for sustainability?
Yeah, definitely. So it's not just the village-in-a-box system. It's an approach that, you know, everything is related to energy. Waste takes energy, water takes energy, everything is related. And it turns out that when you generate electricity, let's say not from solar panels, you have waste heat, which you can use to power other things. When you produce biogas, okay, like Boaz was talking about with our friends from Home Biogas, you know, you also have heat, but you also have fertilizer that is important for agriculture. So it's important to recognize, you know, those places where circular economy can really happen, you know, on a scale that is highly repetitive. I mean, not in those extreme places, but on the places that every time, like when we build a community, and to recognize where this can use for that, where we have some kind of resource that can be used locally. In fact, our government, you know, spends about 300 million shekels per year on industrial symbiosis projects, trying to connect factories, mainly in the south and in the north of Israel, and utilizing their own waste. But we don't have to go this far, because we have those things that happen every day in our own infrastructure that can be easily implemented with existing technologies, and it really, really lowers the cost and really good for resilience and for climate adaptation.
It sounds a lot like you're trying to essentially chase elegance. You're looking for an elegant solution all over the place. Every time there's waste, turn it into feedstock. Every time there's a feedstock, see where you can get it from some waste.
Definitely not every time. It's very important, you know, when we're doing business, it's important to stay on focus. And it's important to recognize those places where it's commercial proven, where you can get financing for that, where it happens a lot. And there are quite a few of those. And yeah, I think, you know, elegance, maybe it's a way, you know, this is how nature works, and we have to learn from nature and implement it.
That's how we do. Yoni and Boaz, you both, I think it's fair to say, complained at some of the limitations of national government not putting sustainability as a prime directive, as a prime mover for how to actually enact policy. But what do you see as the limitations of local municipal regulation? Is it extremely frustrating, or is the scope very large for the sorts of regulatory policies you can put in place?
Can I start?
Yeah.
I think it's a very, you know, it's a very large question. So I'll answer it this way. Tel Aviv and the mayor of Tel Aviv, Ron Khudai, has already upset the national government on several instances, several topics where he decided, or the city council decided to take matters into their own hands. Look at, for example, public transport on Shabbat. I think that when you're talking about climate and environment, air quality, energy, I mean, these are all topics which, even if the local government would make its own regulation and enforce it within its limits, there's only so far you can go, because let's actually have a good example. Runoff management, in Hebrew, Mei Negel. So runoff management, we know the entire coastal plain in the country is actually a giant watershed. So when it rains in the country, all the water flows and eventually ends up in the sea. So Tel Aviv is actually the tip of actually two watersheds, the Yarkon and the Ayalon. So we can make really stringent, we can compose and enforce really stringent regulations on water management or runoff management within our city. But if we get all the water all the way from Petah Tikva and Ramat Gan and Od Sharon and not Herzliya, but you know, by the time the water we get, it's you need to go upstream, and you can only do that through national government. So my answer would be, when you're dealing with topics like, you know, air, water, these things have to be dealt with decisively on a national level.
Form 15 could be a
Form
means for that.
15 is already thanks for mentioning it. It's already a huge catalyst and facilitator. For example, Tel Aviv joined Form 15. Mayor Huldei heads Form 15, but in 2014, I think it was, Form 15 decided to offer the Israeli Green Building Standard 50281, and it was a voluntary standard. But then all the cities in Form 15 made a joint decision to enforce it within their city limits. About 6 months ago, this same building standard became mandatory for the entire country, enforceable 2023. So that's an example of like an initiative of local governments pulling their resources together, putting a proposal on the table, enforcing it, and that new novel initiative a few years down the line becomes the standard.
So it's a beacon of hope, at least. It seems so. Yoni, the village in a box system, it's essentially a modular system. Right? There's lots of different parts within it. Which of these parts would change as soon as the system develops, as it becomes more integrated? Perhaps if it was integrated into the kind of dedicated sustainability rooms that Boaz had mentioned in future building standards, that a residential building might have a dedicated room for sustainability infrastructure. If you could move the village in a box to sort of an en masse application like that, which of these modules do you think would be most likely to change?
So what you're asking basically, if we want to change it into a more city-like solution, how would it look like? So let me tell you this: we already examined it, and we designed a sustainable neighborhood in Mitzvah together with the mayor over there, and we looked at a new neighborhood that was, supposed to be built and not an existing one, and I think, basically it's quite similar to where we are heading, because there is no infrastructure there. There is, 10 meters across the fence, but if it makes economical sense, then you can go off-grid. You can always go hybrid. Yeah. But the beautiful thing about infrastructure that it's below the structure. When you want to go and modify and affect the city, create this sustainability, energy, climate plan, whatever, you have to work on the buildings, you have to be very meticulous, you have to change the infrastructure landscape, the facades, the rooftops. It's hard work on existing cities, but like 70% of the emission comes from our infrastructure, from electricity and from wastewater mainly. So it's a key really. If we change the infrastructure itself, and not even all of it, but like a pre-room where we can, recycle everything locally, and then it connects to the big infrastructure system, then it makes a lot of sense. So you don't have to change and touch all of the urban landscape and go inside. It's much easier. So I think in a city, to answer your question, we don't have any added value with PV panels, which will have to be put according to the architect's will, and we cannot change that. So everything regarded, leveraging the existing energy in wastewater and in waste would be great if we could utilize it locally in our scope. Regarding storage of heat, biogas, cold, and heat. And of course, when you want to manage this kind of multidisciplinary infrastructure system, the software, this is the brain. This is the important thing. And just want to say also regarding the previous question, just a short sentence, that my approach is, that the government really should decide on things, and local municipalities should also work. but sometimes, people like Meir Huldai, which I also follow for many years. I born and raised in Tel Aviv and everything. So they work for themselves. So another good example for someone like this is Dorit Bennett from the south of Israel. She's part of the Southern Arava, very interesting figure. I love her very much. And she decided we're going to check if we can disconnect from the Israeli electric grid to build it all as a giant microgrid or macrogrid, as they call it. We're involved in this project, and we're, what basically they're doing is creating the reality, because the government is not moving fast enough. So, like the high, goals that we set for ourselves with the climate crisis create all kinds of movements in this sense, and it's really coming pressure from all directions. And I'm a big fan of this movement, underground, moving things forward, and it's really creating new business models which are very promising.
Sure. Dorit is making a very strong case for devolved infrastructure. I think that's been very clear. You've both spoken about biogas. Biogas is an extremely interesting idea. We take food waste and we produce energy. We can use that energy to do a series of different things. It's also producing a large amount of explosive gas in a single tank. I do wonder on
safety.
Not so much safety. I think the safety is actually quite cut and dry. It's convincing people that a massive tank of biogas around them is a safe option. And
it's not pressurized.
No.
It's not pressurized. It's even if there's a leak, I mean, it'll just slowly dissipate to the air.
Okay.
It's a greenhouse gas, so it's bad for it's bad for the for the atmosphere, but it's not. It doesn't pose any safety in any sense, providing you don't light a fire next to it.
So flammability would be a problem, but I suppose that's the public convincing part we can get to in a second. That does seem like a competing sustainable technology. The biogas, we're taking food waste and we're producing energy. Maya, with your research, with this seems like a competing technology. Can you list perhaps some advantages to the research you're working on compared to biogas energy production?
Well, as I explained, we find that the main problem is the need to transfer the waste to landfills. And while we're looking for a solution on site of the sorting station, we reduce the need of that. So it's other way to reduce the need to landfill waste and to make some energy product. So it's another solution to the same problem, and from other point of view.
I see. On the topic of generally urban renewable energy generation, few sources of energy, solar being the main one, especially in Tel Aviv and other places. We mentioned very briefly EcoWave beforehand. Now, this to a layman seems like a dream technology. Waves don't really stop. There's always going to be them. The tides come up, they come down.
It's very clean.
Very clean, and it's on Tel Aviv is a coastal city. The entire strip is basically one beach. Do you see this dream?
I mentioned it briefly. So EcoWave, I can compare it in a way to wind turbines. It's very clean. It's investment heavy on the front end, but then there's virtually no maintenance. It's on 24/7. But the reason I compare the two is because, like wind, it needs a threshold for it to be economically viable. And it needs, more specifically with the wave generation, it needs a very particular physical, structure. It needs sort of, you can't place it on a regular beach. It needs to be For example, it needs to be where the waves hit a vertical wall, like you have in Jaffa, like you have around ports, and where the waves have the kinetic energy, which is vertical, and they hit a wall, and it turns into where it's horizontal and they meet a vertical. This is where it's most efficient. So you have that in Jaffa, you have it in Ashdod, you have a little bit in Haifa, and that's it. And maybe a little bit in Rosh Hanikah at the very tip. So that's why the company moved to, they set up a large site in Gibraltar, where they have a large amount of jetties, that's the term, where you have the concrete foundations going into the ocean, and then you can have a series of devices all working in concert. So, I mean, yeah, it's very clean, it's relatively cheap, it's on 24/7, but the amount that you generate, efficiency-wise, is just not, it's not a game changer.
So it's not quite there yet. The engineering is not quite there yet.
No, I don't think it's. I just think it's, you know, it makes sense to deploy it only in these spots. In Israel, you know, it has a very limited coastline, but most of it is natural, and the Mediterranean itself is very, you know, you don't have any, like.
You need a place for where people are surfing.
Yeah.
Real surfing, not like in the short wave stuff.
Yeah.
No. It's not real surfing. Okay, I understand.
I want to say also, I think there is a problem in Israel in terms of, you know, the way that we look at the energy. You know, we like this one gimmick and to go with it all the way. And natural gas is like this, and solar is like this. But it's definitely not enough, and we need, you know, diversity. Why we need diversity? Because when we're going towards a renewable future, you know, we have to adapt to when it's available, and we cannot just go for one thing. We need solar, we need wind, we need maybe wave or maybe tidal. You know, we need energy from biomass and not just biogas, from all kinds of waste, agricultural waste. There are lots and lots of technologies. The same goes for storage. You know, storage is not just lithium-ion batteries. There are many technologies, and you know, like in nature, that we have this biodiversity thing, right? Why is it important, biodiversity? It's important to have all kinds of different species, also in agriculture, because when some kind of epidemic or something, a pandemic comes and wipes out a species, you know, we're doomed. We need resilience. We need all kinds of technologies. And, you know, in Israel, we only understand the language of security and power and war. So we had a real, you know, good example in the last war that we had last month, you know, when they hit an infrastructure facility of gas, liquid gas, and it burned, you know, and they said they're aiming towards our infrastructure devices. So if something like this fails, you know, it can block the whole city, the whole country. And this is, by the way, the predictions. I'm working with a professor from the Technion. This is the prediction either from war or from climate change. And they are, you know, giving those different scenarios and different solutions for that. And, you know, it can also come from cybersecurity. If a type of technology is facing there by itself, it's not resilient enough. So this one gimmick thing is not good enough, and we need to diversify the way we generate and store.
So that seems to be part of the sustainable revolution generally. Move away from monocultures to diverse agriculture, move away from monolithic energy production to a diverse range of energy production methods. Part of that philosophy, and specifically, Yoni, you spoke about this a lot in your presentation. It's very wide-reaching. It's huge. Everything as a battery is a massive philosophical concept. To try and reconceive of technologies and civilizational architecture as being as a battery requires a massive bird's eye view, requires zooming out completely. You are often, both of you, explaining a lot of these concepts to lots of people in lots of different contexts. I guess my question is, how can you explain the sort of sustainable perspective. You have to zoom out, look at diversity, look at resilience. How can you break away from a very gimmicky systems thinking, one way, one problem, one solution? How do you do it?
Look, it's a revolution. It takes time. It began maybe 50, 60 years ago. Okay, we're just now at the peak of it. Definitely, it's multidisciplinary. Definitely not just to technology. You see all the kids in Germany and Sweden now suing their governments for not dealing for future generations.
And winning.
And winning, exactly. And maybe some kids are watching and they want to sue our governments to try harder, right? Not to blame anyone, but to try harder. But you know, times are calling us, and we have no planet B, we have no other alternatives. So it's just, you know, it has to happen. How do we change all of our philosophical thinking about things when the coronavirus came? How did we do it so fast? Because we had to. We had no other option. So crazy times, you know, for crazy measures, and we have to act. So I don't know how, but this is the reality we're facing, and this is what is happening.
I think the question is, I mean, a lot of the frustration that was previously expressed at national government's lack of direction and lack of practical problem solving with regards to sustainability comes from the fact that shift in perspective is gigantic. It's massive. Security is much easier. It's us them. It's very simple. But the sustainable revolution is something that requires a much larger perspective. Zooming in on it, you had mentioned in your presentation, which we previously talked about quite briefly, the possibility of including in future building regulations the inclusion of a room, a dedicated room, just as there are rooms for your bikes, your cars, your bach, whatever. Now there would also be one for energy production. But as you said, there are many technologies and many ways of managing supply and demand. Peaks in energy demand are extremely important, and accounting for those at a municipal or just at a building level could massively save. What could you envision being included in a dedicated sustainability room? I mean, you've got a whole suite of technologies. You can do whatever you want.
To be connected to the roof.
Yeah.
So maybe I got a little lost in translation here. It's not a sustainability room. Sustainability is, yeah, I know it's not what you meant, but it's like Yoni mentioned before. If we're going to build and plan our cities, our buildings more responsibly, it has to be all around. It's the building envelope. I'm an architect, so I think, you know, as an architect, the building envelope is like #1 priority. It's hot out there, but I want it to be nice and cool in here. The better the envelope, you know, the walls, the roof, the windows, the glazing, the flashing, the gas, everything. That's your very basic. So if I'm stepping back, if I'm going to embrace this approach of planning more responsibly, being responsible to the environment, to community, to society, it has to be all-encompassing. But maybe the room is like a metaphorical room. So when I came in here to the room, I looked for an outlet because my laptop was about to die. We all know that we just plug into this outlet and some magical entity far away from here produces energy that somehow gets to that outlet and powers my laptop. The room is metaphorical because we have to start taking our resilience or our resources into our own hands. If we utilize the rooftops for energy generation, or if we make them green roofs, which enhance the biodiversity in the city, and they mitigate runoff, and they help with runoff management, and they cool the city, like I showed the heat island effect, that's taking responsibility. I can put any number of things in that room, but it's I think the room for me is a place where every one of us has to make this shift in their thinking. I have to take responsibility for the impact I make on my life. You know, I have some needs. I need clean air, clean water, energy, comfort, protection. We can't go on, you know, sort of externalizing all these issues. So I'm gonna go with a metaphorical.
Metaphorical. Okay.
Can I ask a question? I'm happy to ask you, Boaz. I really like the plan of Tel Aviv Municipality, and I was also involved, by the way, with Tel Aviv University in the runoff management project that we did. And I want to talk about the next step. You know, we're talking about how to generate energy, waste, and all of those things. But according to all projections, we will still have a lot of CO2 in the atmosphere, about 1 trillion ton. That all experts say that we will also need to somehow suck it from the air, somehow, you know, sequestrate or utilize it. So have you given any thought about utilization, storage, sequestration in the perimeters of the city, or maybe you believe it's something that has to be more done on a national level, agricultural linkage and things like this?
So I have one very modest answer. It's trees. I showed that slide that Mayor Hulday committed to, and I show it on every presentation because he doesn't even remember he showed it, and he didn't write it himself. But when you remind him, he's like, "Oh yeah, we really have to do this." So another 100,000 trees by 2030 means 10,000 trees a year. Now, I'll tell you a secret: we don't have enough space to plant 10,000 trees per year in the city. Not big mature trees like we actually need. So we have to start, and they're not going to do any good in Parque Yalcon. They have to be all over. That's what I can say. I mean, we're like I said, we're the only city we're the only local government in the country that even rolled out such a plan. I don't see it as very ambitious per se, but I see it as sort of changing the tone in the top floor of the municipal building in Rabin Square, because something is shifting. You know, if the city CEO and treasurer start asking me about runoff management and green roofs and adequate trees, and they can list the benefits of trees, I mean, this is already in itself a huge achievement. And I hope the next generation that's going to replace all these guys, maybe my generation, I don't know, will already have this ingrained in them, and it's not going to be seen as something novel.
I think carbon sequestering carbon, the tree is the golden standard. You can use the main technologies you want, but a tree is just going to do it better. Really. It's great technology.
No, I just want to add.
I think it's patent as well.
Sorry?
I think it's out of patent.
Yeah, patent pending.
Yeah.
I just want to add that I really appreciate it, and really it is ambitious. I mean, you have to find places and you have to plant trees. Very important. But you know, my philosophy is the synergy and combining things, and I think food security comes in this sense, you know, not just regarding those community gardens, but regarding kind of municipal food tech facilities, you know, generating food on a local basis, vertical gardening and things like this, which also, you know, absorb a lot of CO2. But I think the major advantage is reducing the transportation to the city for those supermarkets and for those places. So we see always a win-win in those situations, which was always below our nose, but we didn't see. So I think also I remember there was this beautiful container set in the port in the North Tel Aviv, and I would be happy to see more of these. I think it's brilliant. It's lovely. You know, you feel a little bit of nature in the city. So I hope maybe
we have some pilot projects on the way.
We invite you to visit the cafeteria downstairs, the Matanel Gardens, which is from the same company, Vertical Fields. We're doing some work with the RISE Lab as well. But vertical agriculture, in a way, solves all the problems we're talking about. It's carbon sequestration, it's local food production, food security. In the later session, we'll talk about on-site greywater treatment. That is one of the primary uses that you can. It seems like if there were to be new green building regulations, that might have been a technology to include in it, as well as the solar panels on the roofs. That wraps up. We have that's it. We have questions from the audience at all? There, none. Okay, where is that? Well, thank you very much. We've gone through all we were going to talk about. That concludes this session of the first RISE discussions. We'll be back at 3 o'clock for the on-site greywater treatment, where your colleague Clive will be talking. And we hope to see you soon.
Thank you very much. Thank you.
Welcome back to the RISE discussions, number 1. This is our third session. We'll be talking about on-site greywater treatments and a series of other on-site water treatment technologies that we can use to better improve urban sustainability. Our first speaker is Yaron. Are you ready? Yaron is ready. Our first speaker is Yaron Zinger, who will be talking to us about the biofilter project. Yaron, please take it away.
Thanks, Iran. It's a pleasure to be here, just to replace better eyeglasses. Great. So, yeah, I was asked to talk about urban runoff. Urban runoff, or in our concept or vision, it's called a water-sensitive city. So basically, how to address this runoff that we basically discharge out of the city and relate to this as a nuisance, to bring it back to the city as a resource. So this journey took me 15 years, from Israel to Australia and back to Israel. I will go through it. I'll just share the presentation. If I will find it here. That's it. Okay. Let me know if it's visual. Okay. Can you see the presentation? It's okay? Great. Thanks. So it's a long journey project. It started when I joined the team in Melbourne, in Monash University. We got $4.5 million to prove this concept, because they found that the downstream water bodies are being contaminated by algae that grow by nutrients that delivered by the urban runoff. So the Australians came up with the guidelines, water quality guidelines for a stormwater discharge. However, there wasn't a proper technology. So our job, which was my PhD back then, is to develop a technology that will be able to treat urban runoff. And urban runoff holds a big range of contaminants. We'll go through it. After 3.5 years, I presented it, and we got a proof of concept from Viktoria government, and we got a big federal government of $200 million, basically to implement it into 5 countries in Australia. And then I raised my hand and I said, guys, I would like to take it back home to Israel. Why Israel? Because Israel is very dependent on desalination. and because we are surrounded with good friends that aiming our desalination plants, I thought that we need resilient and to have more resource of water rather than just dependency of 90% in desalination. So I came up to my professors and I said, guys, I want to take it home. They were in shock at the beginning, but after a while they agree, and I went back and basically created kind of a competition between local council, and we did a pilot and 2 pilots. Then we had we launched the center, research center in Israel, and I'll go through it. So just a bit of a background about runoff. This is Tel Aviv in the 70s. And this is what happened after 20 years. It's almost fully covered, a lot of roof, concrete roads. And this is, I got from the helicopter, and you see in 2013, it's all not just covered, but we're going up. We're building long-story buildings, meaning there are a lot of people coming in a very small area, and all of this stress is basically create a lot of runoff and a lot of contamination. We shall see. And we identify 4 main challenges in developed countries, in cities. First of all, we understand that we have to create resilience towards climate change, either if it's floods or droughts. In parallel, we see much more people coming to the urban area. More cities are becoming larger and taller. In Israel, 92% of the people live in urban environments, and this is creating stress on the open area as well as our resources. And the third challenge is degradation of the environments. Basically, all the contamination coming from our use is flowing to the streams and create either algal bloom or other contamination of organic matter or heavy metals. And the idea is to recover those streams and to allow access of public to enjoy them. And the fourth challenge is urban heat effect. I think you heard about this one. And when we build a tower, there is pockets of hot temperature in between that challenge our health, basically, either elderlies and infants, and that's become a health risk. So we need to address too. And in Israel, we have another challenge, which is, as I mentioned before, desalination. We are desalinating a lot, 90% of the water balance coming from desalination, and that's very high and risky dependency. So when we bring those challenges together, water sensitive city is basically delivering resilience, access a new and secured water supply. So all the runoff that we can harvest from the roads, from the buildings, from the pavements, we can harvest, treat it at source, and either replenish the aquifer or reuse it to clean our streams and to allow the public to enjoy them and to allow access, and create an effective drainage and flood mitigation. So in order to prevent what we see, that the rainfall regime become much more concentrated and violent. So we need to bring these uncertainties into the future design and infrastructure. And as I mentioned, mitigation of urban heat effect is to create a microclimate throughout the city that will ease those urban heat highland heats, and to allow a better and high quality public spaces. So what's happening with our water? When it's rain, before development, 50% of the water went to the aquifer, and then we could pump it back for beautiful water for drinking, tasty. However, when we develop the city, only even less than 5% is being able to recharge to the aquifer and refill the aquifer. Most of the water, from 55% up to 80%, creating this runoff that collect everything when it flow, heavy metals, organic matter, fuel, petrol, grease, and even sewage. And that's contaminate our streams and our beaches. And this is how it looks in the city. This is one of the 7 drainage pipes in Tel Aviv. It's a big one, you know, it's 3 by 4 meters. There are 7 like this in Tel Aviv. This is in Bat Yam, south to Tel Aviv. Huge drainage pipe. And this is another one in Tel Aviv. You can see the contamination coming from the city. And what we can see also is the quantity, not just the quality, the quantity is enormous, and the infrastructure, the current infrastructure cannot cope with this change of magnitude of events, rainfall events. So if we look at the, sorry, this is in Hebrew, but when we look at the city, this is, for instance, Hadera, and we can also talk about Tel Aviv, about the potential of stormwater. In the consumption of Hadera, this is where I live, so it's 7.5 million cubic meter annually of water in total. The rainfall, it's about 29 million cubic meter a year. So when we convert the rainfall into potential of stormwater, we get 18 million cubic meter per year, which is almost 3 times more of what Hadera consume. And guess what Hadera deliver to the public, to the people? They deliver desalinated water, which they can enjoy natural water. In Tel Aviv, it's 50%. Okay, the runoff potential can cover 50% of the annual rainfall of Tel Aviv, or annual consumption of Tel Aviv. That's a lot of water. In national potential, we're talking about 3 desalination plants, production of 3 desalination plants that we discharge to the sea, and then we pump it back for desalination. So we also losing a lot of power and energy to release the water and pump it back. So a lot of concrete to release and money, and to pump it back for desalination. The aquifer in Israel, the coastal aquifer, is one of the major water bodies, emergency water body, and this is and because all of the construction above, development above Tel Aviv is being very dense. So when it's rain, there's hardly any natural refill of the aquifer. So what we see of levels. So the aquifer deplete below level, and it pulls the sea 1 kilometer in. Every well that was within the stream of 1 kilometer is being saline, so we can't use it for water production. What you can see here on the right is the level map in the aquifer, and every circle is a depression of water. So it's below the sea level, and this is the gradient forming and brings the sea and saline the wells for water, for drinking water. Now, in terms of contamination, what we see, it's basically in 50% of water bodies around the world, adjacent to cities, we see this process happening. Eutrophication, it's enrichment of nutrients, mainly nitrogen and phosphorus, that when it reaches the water body, it creates algal bloom, and the algae use the dissolved oxygen in the water. So the oxygen concentration in the water deplete over time, and then the animals suffocate. You can see the fish, starving for oxygen. And this is what you can see with the algae, and the fish dies, and basically all of this water body become dead, without any life in it. So the concept of water sensitive city is to treat this process, to break this process at the beginning, to prevent discharge of nutrients to the water bodies. How do we do that? So at the moment, when you look outside the window, when it's rain, all the water goes to the pits, drainage pits, and then it flows either to a big pipe, culvert, as we saw in Tel Aviv, and then it's discharged to the streams and then to the sea. Basically, we want to prevent this from happening. And how do we do that? We use one of the main measures in water sensitive range technologies, and this is the biofilter. The biofilter, it's a natural based system. It's basically converting public open spaces into functional public open spaces. For instance, this traffic island is shallow, okay? It's allowed to water flow directly from the road to this system, while if you look outside, most of the traffic islands are elevated. So when it's rain, basically they discharge the water and wet the road. So the idea is to harvest the water at source, to treat it, and then recharge it back to the aquifer. So in a way to do a tikkun, or to bring the status into a pre-development status, when we didn't have roads and pavements and concrete. So the biofilter cross-section is works like a treatment train. So there's the space at the top, which allows some volume to be held, and that creates retention. And then the water flows vertically into 4 or 5 layers. The top layers treat the grease, the petrol, the heavy metals, or any organic matter, while the bottom layers treat the dissolved components, which is the phosphorus and nitrogen. And then the bottom layers basically allowed fast discharge of the biofilter to allow a new or another rainfall event to go in. When it's overflow, we design it to be statistically designed according to the catchment and according to the rainfall regime in the area. There is overflow that takes the excess of water to the next biofilter or towards the drainage system, which become a secondary for now. So what happens when it's raining in the city? You can see on the left, when it rains, everything flows very fast. From the roofs, from the gutter, we see the water runs very fast, and also from the roads. But this is also an advantage because we can collect the water easily. But what it does, it creates a peak of flow rate, which is very high. This peak won't allow to penetrate to the soil because it's too big for the too fast for the soil to absorb. So we have to create a drainage system very large in diameter of drainage system to take this peak out of the city. Now, when we introduce biofilter, as you can see on the right, as a traffic island, you can see the curb is allowing water to flow in. We are managing to cut this peak, allowing two things. One, retention, okay, because it stretches over time. And this retention allows to reduce the flow rate into a level that the soil can absorb, can recharge. And the third thing is to allow contact time between the bacteria and the contaminant. Because we would like to drain, but also we would like to treat the water up to a level that we can use it, recharge, irrigate, or whatever we need in the city. Now, the design could be wide range of applications and design. This is a kind of a cascade of small bays or niches, or it can be kind of small amphitheater. We can see here kind of a swell, and in between them there is biofilters, and also in very dense area we can also have biofilters to collect the water from the street. And now I'm going into the unique pilot that we've done in Israel with the team from Australia. And that's unique in a way because it can work either in winter and in summer. In winter, it collects stormwater from fed of the city, treat it and recharge it to the aquifer. You can see the biofilter here on the right. Okay. This is a new neighborhood in Kfar Sava, which is about 17 kilometers north to Tel Aviv. And we choose this city to start with as a pilot because there's interesting things going on. So we have, this is the neighborhood, okay, and there is a park that surrounds the neighborhood. So we have a big drainage pipe that drains more than 300 hectares down to Poleg stream into the sea. So we locate the biofilter here to be able to get the water by gravity. We monitor the water inflow and outflow, quality and quantity. And then we have an end solution, which is recharge or infiltrate the treated water to the aquifer. So excess of water goes back to the stream without treatment. But this is just the winter scenario. And this project, we designed it to work along the whole year. So what it does in summer, it's connected to blocked wells that were blocked because of aquifer contamination with nitrate. If the guideline for drinking is 70 milligram per liter, in the aquifer we have twice, double, 144 milligram per liter. So those wells are blocked for drinking. You can't use them. So what we've done, we connected to those, connect the biofilter to those wells. So in summer, in the dry season, we can open a tap basically from those wells to the aquifer and treat the water and basically use the same methodology to recharge the water to the aquifer. So this is the first time in the world that we use a hybrid system, winter and summer. In the cross section, it's even simple. We have the drainage pipe that we harvest the water from. The biofilter treat the water, and from here on, it's a new source of water and solution, either direct recharge to the aquifer or infiltration by infiltration wells. So we tested those two methodologies, and there was a big surprise in terms of the results, what to do, how to implement this. And in summer, the biofilter gets contaminated water from the aquifer, treat it, and recharge it back to the aquifer. So we call it an aquifer dialysis process, because the biofilter basically work as a kidney to treat the contamination from the aquifer. So this is winter, and this is summertime. This is how it looks, the design. It's an amphitheater that can hold 350 people, so there are a lot of functions that the city holds here. Those boxes are the research equipment that we can test the water. This is how it looks after rainfall events, and after half an hour, basically it's rain. This is part of the smart research equipment, data loggers, auto samplers, flow meters. And this is the results. As you can see, this is what's running in the Kfar Sava streets, and this is what's coming out from the biofilter. And after this experiment, Kfar Sava local council understood why their wells are being blocked, because if we get high concentration of sediments, like we see here, when it gets to the wells, it's going to block the well. And so when we treat it, we basically are able to secure the recharge with no maintenance. And this is, you can see, this is from 2011, so it's 10 years, and there is no deterioration in the capacity of recharge to the aquifer, and this is another pilot in Bat Yam. So Israel, when we tested the chemically, physically, and biochemically the stormwater, the runoff, we found that Israeli runoff is contaminated 6 to 15 times comparing to the rest of the world, because we get a lot of dust coming from Egypt, a lot of smoke that basically sits, and when it goes to the ground, basically it's hold the contaminates, and when the rain comes, it flows with it. Just quickly about the results, you can see it on our website as well, watersensitivecity.org.il. TSS, this is the dust, okay? 99.5% removal. This is medium, so it's even better than average. Total nitrogen, about 70%, okay? What you see here, the gray, it's what's coming in. This is stormwater, and this is the outflow from the biofilter. E. coli, the biofilter was able to remove log-free, 3 order of magnitudes of what's coming in comparing to what's coming out. And this is basically indicator of sewage, okay, human sewage, and we can see it in every city, in Melbourne, in Israel. And this is the phosphorus, so 92% removal of total phosphorus, and the dissolved fraction is about 88% removal. Now, remember we talked about removing nitrate during summer, so this one was able to get 73% removal of nitrate, meaning the biofilter was able to meet the drinking guidelines for nitrate in Israel. And this is, for me, that was the most satisfactory. You can see this is the well, the recharge well. This is the deep recharge well. It's 87 meters. And this is the infiltration well. And we found that infiltration wells are much more cost efficient because it's much more cheaper, fifth of the cost of the one on the left. And in terms of times, takes 2 days to install, and this is 6 weeks. And so we recommended to use in Israel, at least, infiltration wells because of time and cost. And for me, it was so satisfactory because you can hear the water go to the aquifer, and the suction, when you put your hand on this lid, you feel the starvation of the aquifer. And we did a lot of tests of recharge tests. And when we found that it works, the water authority asked us to do more pilots because to test other scenarios. So we did one in Bat Yam, which is case study of Tel Aviv. And there was no drainage system in these areas, as you can see on the right, before and then after. It looks like a nice garden. And also that creates a nice microclimate when you walk next to it. This is how it looks. And we also did another one in Ramla. This is a city on the edge of the coastal aquifer. And the idea here was to test and test the water, the urban runoff coming from not interstate roads, but inter-cities road that are much more crowded with vehicles, and according to that, the contamination of petrols and heavy metals is higher. So this is how it looks at the beginning. It was kind of a truck parking, and it's becoming a very nice area. And every pilot was adapted by a school or by school or high school to do some tests and to learn about this. So if we sum up the benefit of water sensitive urban design and biofilters as well, the main goal was to protect the receiving waters, to protect the downstream water bodies from this type of contamination, which is considered very wide compared to other contamination, and allowing to reuse this water, either to replenish the aquifer and to pump the water back for reuse. So basically we can have a net zero development, net zero water development, because the irrigation for development is the most expensive cost for the city. It's millions of water bills. I'm in Ramat Gan, and it's about the water bill in Ramat Gan. It's about 6.5 million shekels, which is almost $2 million, just water bill without maintenance. The technology itself is a natural-based system, so there is no energy involved. It's all natural components. The lifespan of the system, there's no lifespan, but we need to refresh it every 30 to 35 years because accumulation of heavy metals, specifically cadmium. What we saw in Australia that it's elevate the real estate value by 17% because people like to be part of it. By using biofilters and water sensitive urban design as a water sensitive city, we are able to reduce the diameter of the pipes by 50%. The implementation is very, as you saw, very versatile. It can be pit trenches, basins, bays, amphitheater. It can also be retrofitted or installed in a new development, which we have less constraints, and it can be easily maintained. In fact, there's no maintenance except gardening, and believe me, I'm not a good gardener, and I never basically treat the biofilter in Kfar Sava because the plants that dies become the substrate, the food for the bacteria. So it's all one ecosystem. So the only thing is to make sure that there is no that it's fully covered. So the vegetation covered the biofilters. Otherwise, there will be a cake of sediments that will reduce the hydraulic efficiency. And also, in terms of irrigation, it requires 50% less compared to conventional urban vegetation. It reduces the heat island effect by 4%. This is not from Israel. This is research from Australia. And the idea is to use it also for other contaminants, such as petrol stations. And when we use biofilter, we reduce the roads erosion because we harvest the water along the flow path, while in conventional drainage pits, it's every 57 meters, so the water accelerate and create erosion that would require maintenance. And of course, what I mentioned is to bring the public into it, to understand it, and to educate. Yeah, that's it from me. I will be happy to answer questions.
Thank you very much, Yaron. That was an excellent presentation. I have just a couple questions, although we are running a little bit over. Just quite quickly, this is an excellent piece of water infrastructure that can be applied in lots of urban settings. Could it be used for greywater?
Great questions, because the concept of water sensitive city is to treat the water at source, and what we have at source is greywater, and also sewage. So we had a pilot in China. I didn't have time to present it here. That we tested the dual mode system, stormwater, urban runoff, and greywater, and it works. We published a paper it was published, a few months ago, and it works. So you can treat greywater with biofilters, and now we're also testing sewage as well.
Brilliant. That all sounds amazing. I have many more questions, but I believe we've run out of time. Thank you very much. If you could unshare your screen, that'd be brilliant.
Yeah, sure.
Wonderful. Okay. Our next speaker is Clive Litchin from the Revital Institute. Previously, we had Yoni Haran, who does some work for the Revital Institute, but Clive is a director of one of the projects there. Clive, are you available? Yeah. Okay.
Hi. Do you hear me? Okay.
Yeah, we hear you and we see you just fine.
Okay, I'm just gonna. Easier for me to hear, and I'll share my screen.
Yes. Clive, if you could continue speaking, I think your audio might have had a problem. There we go.
Okay. All right. I'll share my screen.
Something wrong with the audio? What's this? Give me a sec.
All right. So I'm gonna put my present. Get my. Okay. Here we go. What happened? Oh, okay. Here we go. Okay.
Clive.
Yeah.
Clive, minor technical difficulty. We can't quite hear you. We heard you at first, and then your audio kind of shut off.
Do you hear me now better?
Yeah, much better.
All right. I'll just have to hold the mic like this. Is this okay?
It's perfectly fine. Thank you very much. You can continue.
Okay. So thank you, everybody. Thank you for inviting me to this seminar. So as was said, I'm at the Revital Institute for Environmental Studies. We are a academic and research organization in the south of Israel, and I serve as the director of the Center for Transboundary Water Management. And a big focus of my work is to try to find optimal solutions to communities that lack a centralized infrastructure for water, sewage, and electricity, what we call off-grid communities. So in my presentation, I would just like to share with you some of the work that we're doing in the region. So this is just to give you sort of the global context of what we are dealing with when we talk about communities that lack access to infrastructure. It's a global problem. You're looking at around 1.3 billion people that have limited access to water, sanitation, and electricity. Many of these people live in areas that are either rural or semi-rural. So there's a big issue here also in the role of agriculture. And of course, there's a linkage between providing these services and the ways in which these communities can improve their standards of living, economies, and quality of life. So I work in the region. I work with the Palestinians and with Jordanians and with Bedouin population here in Israel. And you can see that within the Palestinian population of the West Bank, approximately 70% of the Palestinian population can be defined as off-grid in the sense that they are not being adequately serviced by networks. In Jordan, it's roughly 30%. And here in Israel, when we look at the Bedouin population in the Negev, we're looking at about roughly 50% of that population also not being adequately serviced by water, wastewater, and electricity infrastructure. This is just an example of some data that shows you what's happening in the Palestinian Authority. You can see here overall in the Palestinian areas, you can see that if you look at the rural population, the area of the bar colored orange shows you the percentage of the population that is relying on what we call porous cesspits, and a cesspit is basically just a hole in the ground where untreated wastewater is discharged. The great concern of it being porous is that untreated wastewater is eventually going to compromise the groundwater, which is of very high importance for both Israel and the Palestinians because it's one of our most important sources of fresh water for potable use. You can see in the West Bank overall, in again the orange bar, how much people rely on cesspits, and you can also see there to some degree what's happening in Gaza. You can actually see that in Gaza, because of the very high urban density, there is actually greater access to networks, although those networks are very problematic and are not adequately managed, and there's lots of issues, for example, of leakages, low flow, low pressure, and so forth. When we think about trying to promote solutions where we are wanting to offer something as an alternative to centralization, to saying, okay, well, you know, if these communities are not connected to grids, well, why can't we connect them? We are proposing an alternative to the centralized model of providing centrally managed grids, what we call decentralized solutions, and specifically in terms of opportunities for decentralized wastewater treatment. So here are some of the areas that we can provide a potential benefit in a more environmental and more economically efficient way. Firstly, of course, any treatment of wastewater would improve the risk to groundwater pollution. If you treat wastewater locally and on site, you will lower public health risks in terms of there being less exposure to sewage. Very importantly, treatment and then going from treatment to reuse, specifically in agriculture, would provide additional and very important water for irrigation and therefore can improve food security. Next, working at a community level means that you can provide community development, save money, because again, you won't have to require all of these large-scale investments in putting centralized grids in, and you can generate income when you can treat the wastewater and provide that wastewater back to the farmers for irrigation. We've done some cost-benefit models where we can show that decentralized approaches in certain communities are more cost-effective than centralized systems. And when we're talking specifically on how to do this in the West Bank, local solutions are more politically expedient. You don't need large formal government political settlements and so forth. I'll just briefly introduce you to one of our case studies that we're doing now in the West Bank. We work in the Jordan Valley area, which is a very important area in the West Bank for agriculture. There are very large agricultural settlements in the area, but it's also a very arid region with very little access to infrastructure. So we work in an area just north of Jericho, that area there highlighted in the middle map in yellow, in a small town called Al Uja, which is a town of around 5,000, 6,000 people. All of Al Uja is off the grid, meaning that they don't have any access to wastewater collection, and therefore, of course, the wastewater is not being treated. And all of the homes in Al Uja are reliant on cesspits. So one of the projects that we do in Al Uja is to basically do what you see here in the slide, in this schematic. We are we are separating black water and grey water at the point of discharge from the home. We collect the grey water and then we use a modified design of a constructed wetland. I believe the earlier lecturer was also talking about biofilters. So this is another form of a biofilter where we use gravel as a means of filtration. We have the wastewater, the grey water go then through the system. The effluent is then collected in a reservoir, and then we can
Live, I don't mean to interrupt, but if you wouldn't mind holding your microphone a little bit closer, the volume just dropped off. Thank you very much.
Sorry.
Apologies.
No, it's my apologies. Sorry about this. So we have the grey water go through the gravel filtration. We collect the treated grey water, and then we have that water available for irrigation or other non-potable uses. This is a schematic of the system we have put in place in a number of communities in the Jordan Valley. This is called an upflow gravel filtration design. You can see how it works here. We collect the influent. We have a subterranean series of tanks. We firstly do collection, and then with anaerobic gravel filtration, we use those center areas there of the tanks to do the filtration. We then collect the treated water and then pump that water to a small little tower where we could do some disinfection as needed with chlorine or charcoal. And then using the height to generate pressure, we can then send that treated grey water for irrigation. This is just another schematic showing you the design. This is a picture of one of our systems. To date, we've installed throughout the Jordan Valley and in other areas of the West Bank, together with Palestinian partners, roughly about 100 or so of these systems. What's very important is the strong connection between these systems and small-scale agriculture. So what you see here is one of the systems is connected to a small greenhouse. This is a greenhouse of about 80 to 100 square meters, and we're using the treated grey water for tomato irrigation, as you can see here. And just to give you some figures of the benefit of reusing grey water in these localized conditions, one harvest of tomatoes in a greenhouse of this size using 100% treated grey water can produce about 650 kilograms of tomatoes per harvest. One can get anywhere from 2 to 3 harvests per year. 650 kilos of tomatoes can be sold at the market anywhere from 2 to 5 shekels per kilo in Jericho. So we can show quite well quantitatively the economic benefit of this kind of intervention as well. Here's another picture on the left. If you can see the system, you can see more clearly the gravel filtration. The picture there at the bottom is using grey water for zatar, for spices, which is again a crop that has high value in local markets. This is a picture taken in the Bethlehem district, actually near to Jerusalem. A very important issue when one does decentralized or off-grid wastewater treatment and reuse is water quality monitoring and making sure that the quality of the water is acceptable for crops and also, of course, has minimal public health impact. So consistent water quality monitoring is really important when one goes off the grid, so to speak. And here we use online sensors that can report directly accurate water quality data through a cellular or an internet connection to a smartphone or to a website. We work with an Israeli company called Ayeka that provides us with the sensors and the data loggers, and this is just a screenshot to show you some of the data output and the kinds of water quality parameters that one can measure. This is very important also for policy and for the acceptance and regulation of these systems by governments, because with consistent water quality monitoring, we're able then to show that our systems are meeting the wastewater treatment and reuse standards, whether these be Israeli, Palestinian, or any standards really. One of the long-term issues, though, is the issue of persistent contaminants of emergent concern. And we've done some research that is recently published in the literature, showing that even though we are able to get relatively high quality effluent for non-potable use, there is a lingering concern of CECs such as antibiotics and herbicides that we have monitored in the Greywater. So this again is just an additional example of the importance of water quality monitoring and expanding that beyond the more conventional chemical and biological parameters. Another example of our work is something closer to the water energy nexus, the importance of energy for groundwater pumping. This is again a big problem in the Jordan Valley, where the access to electricity is problematic, and this again limits the ability of farmers to access water for irrigation. So we do community needs assessments with the people that we work with, and you can see here just an example of some of the responses from some of our meetings with the farmers, where you can see that the most important issue actually is the high cost of energy for groundwater pumping. And here you can see what the cost is. And so we've also been putting out in various communities in the Jordan Valley localized solar PV microgrids, which can then be used to either 100% contribute to the energy needs of pumping, or can complement the energy needs from the grid. We also have begun to do projects in a small scale off-the-grid desalination, again to improve water quality, because of course the more you pump from groundwater, the more saline one gets, and the salinity issue means that it limits the kinds of crops that can be grown. So we've done some research with, this is just an example of some work we've done with partners from the United Kingdom, and we are testing and doing prototypes of different types of reverse osmosis systems for localized brackish groundwater treatment. Another example is work that we do with the Bedouin here in Israel. So here again, just some data on the demographics. We're looking at about a total population in the Negev of just slightly more than 150,000 people. The Bedouin are the largest minority in the Negev, and you can see here that we're looking at roughly 20,000 Bedouin living in villages that the government has recognized, and about 55,000 living in villages that the government has not recognized. In both of these situations, both in the so-called recognized and the unrecognized, access to centralized infrastructure is also not being adequately provided. And so the Bedouin find themselves in a similar situation to that of the Palestinian population in the West Bank. So you can see here again that they're not being adequately serviced. This is a map showing you the distribution of recognized and unrecognized villages throughout the Negev region of Israel. One of the problems is that Bedouin, because of their close cultural ties to animal husbandry, is a potential risk of animals being exposed to untreated wastewater flows and taking up potential harmful chemicals such as various heavy metals that can be found in untreated wastewater, and that could then be transferred up the food chain to people as well. We have now a research together with Tel Aviv University on monitoring untreated wastewater flows in the West Bank and whether or not one can identify chromium-6 in the wastewater, which is a problematic carcinogenic. So therefore, we are looking at these connections between exposure to sewage, the lack of infrastructure, and disease risk. One clear outcome that has been very effectively reported in Israel through the Ministry of Health is that diarrheal disease constitutes the leading cause of hospitalization in Bedouin infants, and there's a very close connection to this and the lack of sewage infrastructure in these communities. Another problem, again, is the reliance on sewage pits, cesspits, and here's just a little article from the newspaper a few years ago showing that kids can fall into these cesspits, and it's also a problem. Here's a quote from a student that is currently doing her doctorate in this issue at Ben Gurion University from a physician working with the Bedouin, and the quote says the following: "Diarrhea is much related to domestic hygiene. It does not matter how much you will keep the house clean. As long as you're exposed to sewage, it's affecting intestinal disease, especially in children. Dysentery is very common and without a doubt related to sewage. Children's morbidity is high due to waterborne diseases such as Brucella and Giardia lamblia. Dysentery and Giardia are common in children due to exposure to sewage." And the bottom line is there is a direct connection between sewage exposure and morbidity from these diseases. This is what you see in the Bedouin villages. This actually is in a Bedouin village called Batin, which is close to Beersheba. It is a recognized village, but with no infrastructure. So you can see here the risks. The house is completely off the grid, no electricity, no water or sewage. The sewage is just drained through an open channel, as you can see there, and then collecting in a hole very barely covered by that piece of corrugated metal. The other picture is showing you untreated sewage being discharged directly from the house and untreated sewage actually being used to irrigate trees, which of course is also problematic and is not acceptable according to Israeli government standards. So in the Bedouin communities, we are looking at piloting a slightly different technology to what we are doing in the West Bank. We call this technology the vertical green wall. It's another type of biofiltration, but this time we're not using gravel. We use a series of hanging sheets to serve as a substrate or surface area on which the biofilm grows. And then we use a modified version of trickling wastewater to slowly have the wastewater drip down the sheets and interact with the biofilm, and that interaction gets us to a high level of effluent as well. We have piloted this technology in 2 Bedouin communities in the Negev, one near Mitzpe Ramon and the other one near to Beersheba. Part of the design here is to have the system be completely autonomous. So the system here is working with solar power. There's no need to connect it to a grid, and of course in these communities there is no grid, so it's completely autonomous in terms of energy. It's also completely automated through an on-site operation system, and we have sensors throughout the system that gives us information on any potential problems such as blockages or pumps that may not be operating correctly, and we get all of that information again through the internet, either cellular network or Wi-Fi if that's available, and then we can see that all the information on our cell phones or on a computer. This is just again showing you the landscape in which we're working. Very high aridity. This is near to Mitzpe Ramon. The arrow there is where our system is, and we pump the water to this tank here, and then we use the water for irrigation. This is very early on in our project, so you don't really see anything, but we were planting olive trees and using the treated wastewater to irrigate the olive trees. Here's an example of one of the young olive trees being irrigated with the treated effluent. Here is just some results of some of the water quality that we are doing. Again, the issue here of monitoring is essential. Everything that I've mentioned at the moment is still in an early stage of proof of concept and is done quite locally, but we are now moving into scaling up our work, both in the West Bank and the Bedouin. We're now negotiating larger neighborhood projects, and some of the opportunities here that we need to be thinking of is everything that we do, or the work that I do at least at the Arab Institute, because it's very much at a localized level, you have to do a lot of work to engage and educate and work closely with the community. So community buy-in and support is essential. You also need to do everything with the support of local governments. So in the case of the Bedouin, we work with the regional authorities that are responsible for the Bedouin villages. In the Palestinian territories, we work with local city councils or local authorities as well. It's also important to build capacity because you are off-grid, and issues like water quality monitoring and maintenance need to be done locally. We are designing what we call few utilities. Few is simply food, energy, water utilities. So building local capacities, which is partly integrated with the work that we do with local governments. Capacity is essential, so operation and maintenance is very important, and extension services is also important. Extension services here specifically in working with farmers who have little experience or knowledge on how to safely use treated wastewater in irrigation. So we're also building out extended services for both the Palestinian and Bedouin farmers that we work with. A lot of this can also be used to promote different types of localized businesses, especially as farmers now have more reliable sources of water, less vulnerable to drought, and therefore can potentially generate incomes through more diverse and more profitable crops. So we're looking at also building small-scale businesses around these technologies and interventions. And the final issue there is what I call beyond aid, which is how to provide autonomy to these communities so that they can move beyond having to be reliant, for example, on the donor communities. This is especially important in the Palestinian territories, where many of these kinds of initiatives are at least initially funded with through donor organizations. And that's it. Thank you very much.
Okay, thank you very much, Clive. I have a couple of questions. Some of your work is extremely interesting around greywater treatment. Also specifically how greywater treatment can be applied to lots of places in the developed and developing world. It seems almost ironic that in a very developed country like Israel, there would also be regions that are very much third world and requiring these sorts of solutions. The irony being that these sorts of solutions are probably applicable in the very developed parts of the country as well, such as here in Tel Aviv.
Well, I can just quickly jump into that. I mean, it's not just the Bedouin population in Israel. There are, I mean, maybe some of the other Israelis on the webinar will know this, but there are communities all around Israel that are not connected to sewer grids. There are moshavim, for example, in the north that face similar challenges to the Bedouin in the south.
Okay, well, an even stronger case then for the use of some of these technologies for distributed water treatment. I want to pick up on specifically one of the technologies, the green wool that you installed in the system near Beersheba. It's a sort of hanging net with a suspended biofilm you trickle water through. This, from where were you drawing your inspiration for the development of this idea?
That's a great question. So I work with an engineer, and we work together to design a system. And actually, the idea of using these hanging nets, as you describe them actually came through another technology that was developed that actually was first used to actually deal with odor prevention in terms of air pollution. So again, the Israelis will know about HKRITA, just outside of Tel Aviv, which before it was shut down was the largest landfill site in Israel. And of course, there were many, many problems. Sorry, I'm waving, there's a fly. That's why
We can see, we can see.
My apologies. So HKRITA, of course, being a landfill, and now it's a collection site for garbage that actually is brought all the way down to the Negev for disposal. And of course, the communities around were suffering from a lot of odors. So the initial idea actually was that my colleague developed technology using hanging sheets actually to trap aerosols in the air as an odor reducing solution, and it worked really, really well. And on the basis of that, we then said, well, can we use those hanging sheets to also do treatment as a viable substrate to grow a biofilm? Another reason why we're doing this is also because when you work in these areas, you need to be very compact in your technology. Space is not, especially if you're putting these things, near to households or buildings, you don't have a lot of space. So it's a much more efficient, the footprint of the technology is lower and certainly much lower than a constructor wetland design, for example.
Okay, thank you very much. I think some of the engineers in the audience can think of several applications for that kind of technology. Especially, obviously in water treatment, but specifically in some of the distributed technologies that make sense not just for the RFI Institute, but for developing nations and indeed developed nations with existent water quality treatment needs. Thank you very much. I'm going to introduce our third and final speaker. It's Professor Hadas Maman. Thank you very much, Clive.
Thank you so much. Thank you for your attention. Thank you.
Yeah, you can. Hadas, you can present from here. Yeah. Sure. That's actually the mic.
Huh?
This actually.
Okay. Thank you. Thank you very much. So it's a pleasure to be here, and I would like to talk about considerations for adaptation of new technologies, and especially emphasize low-income countries. Water is a destructive molecule, and the reason is that we have 100 times more water molecules in our bodies compared to all the other molecules put together. So if we think about ourselves as humans, okay, we assume that we're humans, but if we look at ourselves from the molecular point of view, we're more water than anything else. There's a book called The Wonders of Water, which talks about the hydrogen bond in action. It's not an action movie, but it talks about the hydrogen bonds in action, which is really interesting. So what is the sustainable water approach? Let's look from the water point of view. Again, because remember, we're more water molecules than any other molecules in our body ourselves. So when we think about water innovation and looking out of the box, what does it mean? Because everyone wants to say, hey,
find a technology that is out of the box, that is innovative, that is something else. But if we dive deeply into the 3D dimension of water, we really need to, from the way that I see it, we need to feel water, understand water, and imagine water. And this is the only way I think that we can really look at water. And we must remember that water is actually H2O that interacts with other water molecules and with all the other contaminants that are present in water, in what we call water. When we look at the Hebrew word of water, water in Hebrew is mayim. Mayim actually starts and ends with the same letter. And this comes back to the circularity of water also in the Hebrew and the ancient thought process of Judaism about water. And if we forget about the scales, we really need to understand that water is a universal solvent, and water will accept everything that is imposed onto it. And therefore, as a society, we have the obligation to treat water with its respect. So we can see here that water is actually a network of infinite water molecules that are joined together in various dimensions and various clusters, and it depends on the pressure of the water, the temperature of the water, and different factors. However, understanding the physics of the water and the 3D dimensional status of water molecules that are interacted with each other is very complex. Actually, there are not many researchers in the world that know or understand the clustering of water. They do understand the chemistry of the water, the microbiology of the water, or the physical parameters of the water, but really understanding how the water molecules interact with each other and with other contaminants in water, this is highly complex, which science did not solve this problem yet. And even there are like other thoughts. So can sound impact water? Can light impact water? And how does this interact the interaction of water and the way that we purify our water? So these are really complex things that I hope and I believe that at some point in our human development, we will understand more about this amazing thing. So let's look at water from the human perspective, right? Because we're humans, we always like to look at things from our perspective, seeing ourselves as the center of the world. Water can accept a wide variety of conditions and molecules, but we are humans, we're actually very limited. If we look at microbes, microbes are much more adaptive than humans. So we are not that developed from my perspective. If we look at what's happening in the world, more than 2 billion people suffer from water that is contaminated with feces. So I would like to say that although the climate crisis is the most sexist crisis available, actually water, we cannot survive without water. And if we think that, if we know that more than 80% of the sewage is not treated worldwide, and that 2 billion people suffer from water that is contaminated from feces. And this is talking about the quality, but there's also the issue of quantity, having too little water, too much water, and all these issues. This is a very complex issue. So within the water, we have different contaminants in the water, which can result from metals, pesticides, herbicides, microorganisms, and we need to look at all these in the water. We are limited, as I said before, and if we even look at this molecule here, we can see phthalate, which is only one molecule out of a huge list of water molecules, of contaminants that can contaminate water. And this molecule actually can contaminate groundwater sources from open dumps, because the plasticizers that are contained within the plastic bottles can dissolve in an open dump due to the temperature conditions, and this can contaminate our water sources. Actually, this molecule is carcinogenic. And so we have many issues with water that we actually need to solve. In addition to that, we need to also sometimes understand that there are some basic things, because as I said before, many people in the world do not have access to basic water that is disinfected. And I'm not talking about chemical contaminants, I'm talking about biological contaminants, the basic disinfection that people do not have. Technology is there. There's no reason today that people will die due to diarrhea because we have all the technologies to solve the issue. Then where's the gap? Why are these things still happening? Why is there limited infrastructure? So before that, it was discussed in previous lectures that infrastructure is an issue. So we must decentralize. We must look at how can we decentralize our technologies in order to fit various considerations like piping issues, electricity, supply chain, and unskilled personnel. If we look at the current technologies that could be relevant for decentralized locations, in low middle income countries, we know that chlorine is there to disinfect the water, but there is an issue of supply. In addition to that, filtration systems, they need electricity. And in cases where there's intermittent electricity, it's also an issue. So they have heavy maintenance, and this is, of course, a problem. So what is the message? What is the most important thing? Technology is there, but in order to make a change and to adopt new technologies, we really must look at both the social and the technology-based parameters together. And in order to demonstrate an impact or a change, we really must understand what is the social impact of the new technology. And there's also a basic thing of introducing no harm to the community. So this is also a very important issue before we implement new technologies. In addition to that, there are various thought processes on water. If you read water philosophy issues, and there's an issue of the fourth industrial revolution in water, which should actually bypass the traditional thought processes. And this should look at accelerated innovation in order to find solutions for poor water quality and the impact that it has on society and the environment. So we need to develop disruptive technologies to leapfrog over the current practices. But how can that be done in low-income countries? Like, is there a chance? Is there a possibility to do that? But again, before we even start to think about what we can do with the water, we need to understand. We need to understand the local context. We need to understand the perception of the communities. And three very important parameters in order to understand how to adopt technologies are the knowledge. So what knowledge do we have about our water sources? What knowledge do we have about the water technologies that are available? What is the attitude? How do we value water? Do we value water at all? And if we do, how much do we value the water? In addition to that, the practice. So what do we do with the water? How do we collect it? What are the technologies that are commonly used in those local communities? So, and what are they used to do? So are they used to boil the water? Are they used to add chemicals to the water? Maybe barks, leaves, and other type of practices. So it's really important to understand before we start implementing a new technology to understand the KAPs within this technology. I'd like to shortly talk about a research that we have with HKRITA University. This is a combined research between Tel Aviv University and HKRITA University. With this project, we try to map the different types of water that the people were drinking in various local communities. And when we mapped the water, we saw that some of the water sources were piped, other were collected from public sources. There's also on-site owned household treatment facilities such as rainwater harvesting or private wells. In addition to that, there was water that was delivered to storage tank or packaged bottles and cans. If we think about ourselves, we open the tap and we drink water. But when we look at those low middle income communities, these are mostly low income communities, they have a variety of water sources. So how could we expect when they have a variety of sources or maybe they lack even a variety of water sources, how can they treat the water? And what are our expectations? Because when we open the tap, our water is clean. But in these communities, the situation is different. And what we found is within our survey is that most of the people actually did not trust the water that was delivered to their household. So this is a very complex issue. And because they did not trust the water that they were drinking, the water underwent through various household treatments. So for example, if we look at this slide, we can see that the water was either boiled or traditional materials were added to the water, also settling, and also a combination of boiling traditional materials and settling. So just imagine that you have your water at the household and you need to do all these treatment technologies in order to improve the water quality. This is crazy to think because we're just used to open the tap and drink our water. And this is, I think this point was really puzzling for me because actually 80% of the households in our study were treating the water before they were drinking it in their homes, in their household level. And that was actually labor intensive. In addition to that, the materials that were added to the water, we were surprised because, for example, we found that the jeera, the roots and the barks and the ginger and all these medicinal plants were added to the water. The water was allowed to settle. It was boiled. The water was boiled and then settling. And what we found, for example, is that the addition of these materials resulted in reduction in turbidity and increase in ORP. So just think about it. The materials that were added reduced the particles and increased the ORP, which means that the water had more oxidative power. So this is maybe similar to adding chlorine to the water, where the water has a higher oxidation potential. This is amazing, and even this thing should be researched more to understand the addition of materials to the water. Then we tried to understand the perception of the community that was drinking the water. We were actually surprised. The people that thought that the water were very bad found that the water had either diarrhea or yellow fever. Yellow fever is more relevant to water that is actually stored, and not water that is treated. In addition to that, we found that there was no relationship between the awareness of the people about the public treatment to the water quality at the source. And this is also surprising for us. So what we found, to make a summary, we found that actually the water, although it was boiled, treated, chemicals were added, different materials were added to the water, still the quality was not sufficient. And that's why we thought that maybe UV disinfection can actually result in improve the water quality. But how can UV disinfection could be implemented at the community level? So this is actually very interesting. In order to understand, can we use new technologies that are not used generally into various communities? Another new technology that we're now starting a pilot study in one of remote communities is using UV LEDs. So LEDs have many advantages because LEDs are DC operated. They can be operated with a solar sun. They are turned on and off immediately, just like the light in the room, and they can actually be very compact. And they can be integrated in various ways. So they can be integrated into the water storage tank. They could be integrated into the bottle that the people are drinking. So we're kind of trying to see how can we leapfrog? How can we take these new technologies into the developing world in order to try to solve the challenges of these water that are not disinfected? When we try to understand where UV disinfection is implemented in the communities, I'll just make it like really short. We found that there were some communities that did use central UV disinfection systems. They used low pressure lamps with 16 millijoules per centimeter square. And what we found is that there were various challenges. First, in some places the flow rate was higher than needed. The filtration systems were not backwashed as they were supposed to. There was no indication when the filter is clogged, when the filter should be changed. In addition to that, there was no indication when the UV lamps should be replaced, because
because the people in the community did not know when they actually started to use the UV lamp. And this is also a huge issue, because if the technologies are there, but they're not operated according to what they need to be operated, then there will be, of course, the goal or the impact or the idea of providing safe water will not be there because the technology is not operated as they were supposed to be. What we also found is that in the storage tank, there was the regrowth of microorganisms, which shows the complex issue of having storage tanks. In addition to that, we found that E. coli was present in some of the samples, and other coliforms were present. And actually, that the turbidity was above even the permissible limit. So therefore, when we think about technology, when we say to leapfrog, it doesn't mean that we have to have the most advanced technology. It means that we need to think smartly about the technology. And the students in this project actually designed a low-cost semi-automated system that in $200 can tell the people in the community when do they need to replace the lamps, when do they need to backwash the filters, when the storage tank is it reaches its limit of water storage capacity and all these things. So it's possible to leapfrog, not by having the most advanced technology, but to operate the technologies correctly. And I'll just like to conclude about the thoughts. 50% of the technology in interventions in the developing world fail. So tons of money that is being dumped to that, just dumped. And why are these things happening? Because of the small case studies that I showed you. They purchase the technology, it's not being operated correctly because the expectations do not match reality. And whenever there is expectation and reality that do not match, there is the point of pain. And the point of pain is that water that is supposed to be purified and disinfected does not reach the people and humanity. And this results in death. So therefore, I'd like to just summarize is that in order to adapt new technologies, we really need to think out of the box and to leapfrog the current practices. Thank you very much.
Thank you, Ada. So this is the head of environmental engineering here at Tel Aviv University and also my own professor. So to ask her questions about this research that we did together would solid. But I do want to ask, the difficulty with 50% of all interventions failing in the field, this is because there's a gap between practice and between training, or practice between supply chain. What is the general strategy that we should be using to leapfrog this problem? We should be using to implement interventions, not just in developing countries, but in pilot studies here and in other developed places in the world, that can ensure that these technologies are sustained and therefore sustainable.
Well, this is the, I don't know, say the 100 million question or yeah, dollar. Yeah, this is actually a very difficult thing because I think that many people try to understand why technologies fail. And this is because usually engineers talk within themselves. So they don't talk with people that come from different disciplines like social sciences, policymakers, psychologists, even people that deal with the history of the location of those places to understand it. First, we need to understand that it's not like there's one thing that fits all. And the complexity is that each technology needs to be adapted according to the local context. And that's very difficult because you need to understand what are, as he said, what are the practices of those people in those places? What knowledge do they have? What is their attitude? Do they want to do it? Are they open to change? There's also the theory of change. So where are the places that change could be, you know, have the most impact? So yes, it's a complex issue, but it's possible, I think.
I hope so. I do hope so. Thank you very much.
Thank you.
I believe that concludes our first RISE discussion session. We hope to be back in 6 months, perhaps with more speakers, perhaps with less. I guess we'll see. Thank you very much for attending, and I hope you've enjoyed the day. Bye.